A lot of super popular websites on the internet use NextJS, namely CoinMarketCap, Spotify, and even OpenAI's ChatGPT. In this video, you're gonna learn how to create your own API service using modern React and NextJS. By the end of the video, you'll have built and deployed a complete API service web application. If you're new here, my name is Josh. I'm a web developer based in Germany, and I've worked a lot with Next.js in the past couple of months, especially Next.js 13 for my own startup, but also for open source projects that I've done here on the channel. Don't worry if you only know the basics of Next.js, that is fine, or if you've only worked with Next.js 12, we're gonna go from simple concepts and then move on to advanced topics later in the video. The website is going to be fully responsive, it features a beautiful light and dark mode, and we're also going to implement rate limitation for the API service that we're creating together. The table that we're going to use to show users their past requests is super functional. We can hide and filter by columns, we can sort up and down. It looks really good in light and dark mode and is super functional. Alongside building your API service, you're also going to learn how to use Typescript and TailwindCSS, both of which are really popular and in demand. You'll learn how to handle loading states in Next.js for the best possible user experience, and also how to protect sensitive routes so nobody that is not authenticated can access those routes. As I said, we're gonna start simple and then move on to some advanced topics. First, we're gonna lay the groundwork for the project and then move on and build step by step. And I'm gonna take you with me all the way from the first dependency installation up till the deployment. We're gonna deploy this project together. It's gonna be the full journey in this single video. Hey, so before diving into the code together and coding this out together, let me show you and demonstrate to you exactly what we're gonna build together. So this is the homepage. It looks pretty nice. We've got a little 3D animation here for the text, and we can toggle between a beautiful light and dark mode. And by default, the system mode will be enabled. We've got this little image right here that I'm also going to provide to you if you want to use this for this application. We've got the documentation page, which is fully mobile optimized, so you can also scroll on mobile. It has animated code for Node.js and for Python, little tabs that we can switch to. Also, we have a full authentication feature, so we can sign in. This will work with Google. Now, my Google account has already logged me in automatically. That's why it didn't prompt me to log in again. And in this dashboard, we can generate our API key that we can use to make requests to the endpoint in the documentation and get the similarity of two texts. So to try that out, let's request an API key that's gonna generate a unique API key for us that we can then use right here in Postman to make a request. We can pass this API key in the authorization header, and in the body, we can pass along the properties we demand in the documentation. So text 1 and text 2, we can click send. That will send along a request to this API route with our authentication token. And because we generated this token for ourselves, we know it's valid, and the similarity between these two texts is 0.83. That's only part of this project though, making that API service. If we refresh this page, it's gonna prepare our dashboard where we can see a beautiful table with all API requests that we have ever made to this API endpoint, with the duration it took to generate the answer, the status, the recency, the path, and the API key we have used. There's a bunch of options right here. We can copy the API key into our clipboard. We can also create a new API key, so the old one will be invalidated. And we can check that. We've just invalidated the old one. We can send another request, and right away the error unauthorized pops up. We are not allowed to make the request with the same API key. We could also just revoke the key, so it's not valid anymore, and right now we don't have any valid API key. And we would have to request a new one for this to work. So this is really cool. I'm very excited. There's a lot of cool features in here. And I think we can now get started in building this out together, step by step, starting at the simple concepts and then step by step moving towards the advanced concepts. Okay, before getting started with the actual project, I just wanted to let you know there is a GitHub repository for this. So if you get stuck at any point, you can easily compare the code you wrote to whatever code is right here in the repository and get unstuck that way. Okay, and with that out of the way, let me close this down. And let's get started with this project from scratch. And to do that, I'm gonna press Windows button and R, type in CMD to open up the command line, and then we can get started with a whole new NextJS 13 project on the desktop. So I'm going to navigate to the desktop and then say npx create -next, let me zoom in a bit, -app at latest. So that means we're going to be using the latest version of NextJS, which is going to be 13.2.3, I believe. And then --experimental -app, and then hit enter. That's going to initialize the NextJS app for us. We're going to call this similarity -YouTube, because I've already got the similarity -API where I coded this out before filming this video. We are going to use Typescript. However, as I said, I assume you're completely new, and I'm going to walk you through every step. We also want ESLint, so we can get better code practices implemented. Yes, we want the source directory, and then we're going to configure the import aliases ourselves. If you don't know what that means, don't worry. It's something that we can do inside of our projects to make the imports look a bit cleaner. So instead of having the .. / all the time in the imports, we can just use an absolute path from the root of our project, and you're going to see what that looks like here in a second. So let's open up this project. Open with VS Code. It's going to open here on my left, and here we are inside of a brand new project within NextJS 13. Okay, now the first step would be to install all the necessary dependencies that we need. So we can open up the terminal here on the bottom and close this for now. And we want to install a bunch of dependencies that we're going to need. Now, to determine which ones exactly we need, these are the ones we already have, and we're going to extend them right now. So I'm going to say yarn add, but you could also say npm install. It really doesn't matter which package manager you use. And then I've got the package.json here on my left side, and we are going to start installing some dependencies. So first one is going to be at emotion /react, and the second one is going to be at emotion /styled, and then the at MUI. So we're going to be using material UI for this /material, and also at MUI /system, and at MUI /xDataGrid. Now this data grid right here is super interesting because we're going to use this data grid to handle the logic inside of the API dashboard. So the table I showed you in the beginning, that is done with MUI xDataGrid, super powerful library that we're going to use, and I'm going to show you how to use. Then for the authentication, we want the next-auth /prisma adapter that we're going to use to handle the sessions in our database. So we're going to connect the next-auth with the database that way. Then we want at prisma /client for the client-side types of Prisma, because we're going to use Prisma for database management. Then we want at radix -UI /react drop-down -menu, and also at radix -UI /react scroll area, super handy, and also at radix -UI /react -tabs, and that's all we need from radix UI. If you don't know what radix UI is, it's an unstyled and, in my opinion, the most underrated library there is. Radix UI. It got acquired recently, so they stopped marketing their components, but they're primitives, so you can style them however you want, but the accessibility and the features are all in there. It's super underrated in my opinion, and we're going to leverage the full power of Radix UI in this project. That's everything with Radix UI. Then we want at total Typescript /ts-reset to get some better types within our project. We want the rate limiting stuff. That's going to be really cool. At /rate limit and rate limit, and at /redis. We're going to use those two for the rate limiting. Then we want class-variance-authority to handle reusable classes for our components. Then we also want CLSX and date-fns to handle some date utility functions. We want ESLint is probably, it's already in here. We don't need to install that. ESLint config next. We've also already got in here. Perfect. We want framer-motion as a peer dependency. because I think that is for Redux UI, they depend on framework motion. Then we want Lodash for a certain scrolling behavior within our application. You're going to see that later. We want Lucid-React for icons. We want Nano ID for generating the API keys. We want Next, okay, we already got that. We want Next-Auth for authentication, the best package for authentication in Next.js, in my opinion. And also Next-Themes for the beautiful dark mode you saw in the beginning of the video. OpenAI for creating the actual embeddings. You're going to see what that means later. Then a Prism-React-Renderer. And yeah, this is a lot of dependencies, but this is a real project that we're building together. And in real projects, you are going to have a lot of dependencies. That is completely normal. The Prism-React-Renderer is for the documentation page for the code highlighting that you saw earlier. So for this behavior right here, when we go to similarityAPI.com, the behavior you saw on the documentation page, let me close this down, right here, the animated code, that is what this highlighting is for, the Prism React Renderer. Then we want Prisma for our database, and then that's almost it. We still want React, actually no, we don't need that at all, no. Then we want React Hot Toast to extend that for the toast notifications. We want Sharp for better image optimization within Next.js. Simple bar-react to make this component I just showed you mobile accessible. So that means when I make the page way smaller, we can navigate this with this horizontal scroll bar. And then there's two dependencies left that we need, which is one Tailwind-merge and the other one being Zod for server-side schema validation. And that's it. I'm gonna hit enter. This is probably gonna take some time to install. And we're just gonna let it install and see what happens. I think, or I hope I typed in everything correctly and you did too. If you forgot some of these dependencies, remember there is a GitHub repository. You can go to the GitHub and then into the package.json and see all the dependencies that we need right here. Let me close this down and let's wait for this to finish installing. Great, so it has finished installing all the necessary production dependencies that we need. One thing we still want to do is install TailwindCSS. So let's get to TailwindCSS for Next.js. There's a specific guide for that. And don't worry if you've never used TailwindCSS. I'm going to walk you through it every step of the way. So to get started with Tailwind, we want to copy this command right here. npm install or yarn add these three dependencies as dev dependencies. So let's open up the terminal and then say yarn add -d or npm install -d for dev dependencies. And let's remove the duplicate. And then Tailwind-CSS, post-CSS, and auto prefixer. And we also probably, because Next.js uses npm by default, want to delete this package log specifically if you're using yarn. If you're using npm, then that is just fine. And then run that again really quick. Perfect, we got rid of the unnecessary dependency log. And then we want to initialize Tailwind-CSS. Now to do this, we are gonna run yarn and then Tailwind-CSS init -p to initialize Tailwind-CSS. That is gonna create a tailwind.config for us. We can close the terminal. And to use Tailwind-CSS within our project, we can copy this Tailwind config that they've already laid out for us into right here and save that. Because we're using the source directory that we enabled in the command line interface at the start of the video, we are going to use this line right here. And that is just, to determine which file paths the Tailwind styling is going to be applied to. And last thing we want to do to get Tailwind up and running is copy these three directives into our globals.css. And that's going to be at Tailwind base, components, and utilities. And let us see what happens. So I'm going to type in yarn dev or npm run dev if you're in the npm environment. We're going to allow this. And then that is going to start up on localhost 3000. So let's do a little split screen right here. And let me go into my browser, type in localhost 3000 and give this a hot second to load. And that seems to have worked just fine. Yeah, the split screen. Yeah, there we go. This looks better. All right. And then in here, let's go into our main page.tsx and see if Tailwind is set up correctly. we can get rid of everything that is already in here, and then just render a main that says hello world, and let's give this a class name of background red 500 to see if Tailwind is set up correctly. And it is great. So we see hello world with a background red of 500, and that means that we set up Tailwind correctly. Great. I think the first thing that we're gonna do is create reusable UI components and get some of the folder structure laid out so we can then work confidently within our project. I'm gonna get rid of some of this stuff right here. We don't need those. We can delete the favicon and the module.css, and the rest is necessary. So 2 components we're gonna be reusing across this whole application are gonna be a paragraph and a large heading. So let's create them. We're gonna go into our source directory and then the app, and then here we're gonna create a new folder called components. And inside of this components folder, we could also create the UI already for components that we're gonna reuse very often that are kind of unstyled. And then in here, we're gonna create the file called paragraph.tsx to create our paragraph component. Now, I've got a really handy shortcut that is FC, and if I hit spacebar, it's gonna create a TypeScript component for me, like this. So we can see the cons paragraph and then the FC, which stands for functional component within TypeScript. And this functional component takes a generic. Now, a generic is some abstract concept that TypeScript gives us. Essentially, I'm telling the component that the paragraph props we can define up here are gonna be the type of the props that we get in this component. So if I were to say we're gonna get a text for this component, for example, which would make sense because this is a paragraph after all, then TypeScript wouldn't know which type this text is, and therefore we could put it up here and then say this text is of type string or Boolean, whatever we want. Now, Boolean wouldn't make sense for text specifically, but I think you get the concept. So we're telling React that this is a functional component type, and then passing the type of the props that we're going to receive that we define up here. Now, this paragraph is not going to take the text like that, but instead we want to make this really reusable. So I'm going to say const paragraph variants. So we're going to define certain variants of this paragraph. Now, this is going to be super interesting because this is going to make this component very reusable across the whole application. And to define these variants, we're going to use something called CVA. Now, CVA comes from a dependency we've installed already, which is called class variance authority. So let's import CVA from class variance authority. That should work just fine. And what this allows us to do is, first thing we can pass into this function is the styles that will always be applied to this paragraph. Now, in this case of the application, that's going to be a max width of prose, which is a Tailwind term we can determine, or we can use to give this a maximum width of a certain prose, which is like, I'm not sure how much exactly that is. You can take a look at that, max W prose, hover over that, that is 65 ch, that is the width we're giving it right here. We don't want that on the div. And then text slate of 700, that is going to be the text color equivalent to CSS. Then dark, a text slate 300. 700 was the light mode, a margin bottom of 2, and also text dash center. Great. Let's format that using prettier, and those classes will always be applied to this paragraph. And then as a second argument or parameter for this function, we can pass the actual variance we want to exist of this paragraph. And that's going to be the size of the text for one. The default size of the text is going to be text-base, which is a Tailwind term to determine a font size. And then we also want a small of text large. So on mobile devices, the text is going to be a bit bigger, so it's easier to read. That's going to be the default styling of this paragraph. And then we also want a small variant of this, which is going to be text small, and then also small text base. So on mobile devices, this is all again a bit larger and better to read. And then we can pass the default variance for this, default variance. So right now we've defined the certain properties that this paragraph could have, but we've not told it what it should be by default. So we call this default, but it is not the default value yet. We still need to set that in here. So we're going to see the size. By the way, I opened this interface with control and spacebar so we can get the full type safety. The size is gonna be default or small, both of which we've defined up here, and we're gonna choose default. Okay, great. Now we've defined our paragraph variance that this paragraph will always have, and now we want to define some props this paragraph can take. And because we're working in TypeScript, we can leverage the full power of TypeScript to do this and extend this interface by the HTML attributes that we get from React. It's a type. This takes a generic again. I've already explained what a generic is. It's kind of like a function in JavaScript, but instead of passing parameters, we are passing, or instead of passing arguments, we're passing types. And then here we want the HTML paragraph element. So that means wherever we render this paragraph, let me go into a different page right here. Say we wanted to render the paragraph right here. We can import that. And then as you can see, when I see which props we can pass, we can see all the props that a paragraph element in HTML could normally get because we did this extension of the interface right here. And then also we want to extend this by the variant props. This takes a generic again, and let me format this. This takes a generic, and we want to pass the type of paragraph variance right here. So what we just did, if I save that, is instead of the normal props that a paragraph could always take in HTML, now, as you can see, we see the size option. And if we see what we can pass as the size, it is either default or small. So whatever we have defined in our paragraph variance up here. And that is super useful because now we can render the small size and the paragraph will always look the same wherever we render it in the application. Why is this not working again? Like that. Okay, great. Now the styles are not being used in the paragraph just yet. To do that, we are gonna turn this into a forward ref at first. So what we're doing right now, we're importing the forward ref from React. And what the forward ref does is it allows us to pass a ref, so a link to a certain DOM node to this component. And you're gonna see what that exactly means later on. So if I go back and we try to pass a ref to this component, we couldn't. It doesn't take a ref property. However, if we use this forward ref, then wrap the whole component within that, and also import that from React, then we could pass a ref to this component. And as I just said, a ref is a link to a DOM node. And this ref takes two generics this time. So again, generics, what we did up here already. And the first one is going to be the type of whatever we're going to be rendering. It's going to be an HTML paragraph element. And then the second is going to be the type of the props that we're going to pass, which is this paragraph props we've already defined up here. So we can pass that as the second generic. And now we can see all the props that we could receive in this component. Now we are only going to destructure a few of those, and those are going to be the class name property that we could pass from anywhere where we render this paragraph element. Then we want the size, the children, and everything else we're going to receive as ... props. Now, the second argument, because we did the forward ref, is going to be the ref to an element that we don't have to pass. It is optional, but it is a best practice to always allow accessing this element programmatically from wherever we render it. Great. Now in the return, we're going to have a p because this is a paragraph element after all. The ref, we're just going to forward to the ref. That means if I were to render out the paragraph in this component right here and pass a ref of, I initialize a use ref up here and then pass that in here, then essentially that will create a link from that ref to this paragraph element right here. That's why we're doing this. But we don't want to pass a ref just yet. Then the second one is going to be the spread and props. So whatever we pass from the parent, we don't even care. We're just going to pass it on to this paragraph component. The class name is going to be a dynamic class name. And for that, we're going to define a utility function. Now, utility functions, let's create a folder. And this folder we're going to call lib for library, essentially meaning that we are preparing certain libraries inside of this folder to be used in our application. And I can make this way larger. We don't need the website right now. Okay, now we've defined the lib, and in here we can define a folder, or in our case, that's just going to be a file called utils.ts, because It's just going to be a few utility functions. It's nothing special. Actually, it's just going to be one. And this function is going to be called cn for class name. This is going to receive a bunch of inputs of type class value array. Now, if you never use Typescript, the way we define a type inside of a function is inside of these parentheses, we can say a colon and then the type of whatever this is. Now, this type I didn't define myself. This comes from the library, but it doesn't come from that. That is a wrong automatic import. It comes from CLSX. That's where we get this type class value from. We can also say import type. That's going to make this a bit easier. And then this function is going to do some merging for us. So we're going to return a TW merge. That is what we get from the Tailwind merge library we've installed at the beginning of this video. Essentially turning code like, if we were to pass padding y of 2 and padding x of 2 to a component for a class name, then Tailwind merge would turn this into padding of 2. So it optimizes the class names that we pass it just for some better, readability and maintainability. And in here, well, first off, we need to import that Tailwind merge. So let's say import TW merge from Tailwind merge. That's just right, GitHub Copilot. And then in here, we're going to pass the class name CLSX and just input we call it inputs. There we go. Okay, so this is going to handle the conditional logic for us, and Tailwind merge is going to merge the classes together for us. That's what this is going to do. And we can call that inside of the class name for our component right here. So we can import the cn function we have just created. Let me go back to the paragraph here. And then in here, we want to pass the paragraph variance and just spread in the size and the class name that we receive to use the variance to also use whatever class name we pass it wherever we render this component. And we're almost done with the paragraph. Last thing we're going to do is render out the children right here. There we go. So whatever is inside of this paragraph, wherever we render it. So say this wasn't a self-closing paragraph, but there was some text in here. The some text would be considered the children to then be rendered out right here. And that is what we're doing. Great. I think we are almost done. Yeah, we're almost done with our paragraph. One line is missing, paragraph.displayName. This is for debugging purposes. By the way, the display name is going to be paragraph. So we do that because we're using a forward ref, and we also want the display name inside of our component right there. And that is our paragraph done. Great. We can get rid of all the unused types. And we're going to do something similar for a large heading. So let's say large, or we could just call this heading. I'm going to call this large heading because it is going to be pretty large. And what we can do is just copy this whole thing and change some stuff about it. So instead of a paragraph, this will be an h1. Obviously, we don't want a p tag, we want an h1 tag. We want to change this to an HTML heading element. And the paragraph props are not going to be called paragraph props, but large heading props. Now this doesn't exist yet because we need to redefine this. And that is going to extend by the HTML heading element instead of the paragraph element. And we don't want paragraph variants, but heading variants. Now these don't exist yet. We still have to define those. So first, let's define which classes this heading element will always have. It's going to be a text of black. In dark mode, that's going to be white though. Then a text of text dash center on large. That's going to be text left, just for some good responsive design. Then font is going to be extra bold, so super bold, leading dash tight. That means the letters are going to be closer together, and then tracking dash tighter. Actually, that might mean the letters are closer together. I think they essentially mean a very similar thing. Okay, now for the heading, we're going to define 3 sizes. One is going to be the default. This text is going to be way larger than the paragraph because this is a heading after all. So we want the text to be 4XL. Then on medium devices, we want it to be 5XL. And on large devices, this should be 6XL. Then the small variant is going to be a text of 2XL, medium text of 3XL, and large text of 4XL. And we also want to define a large variant for this large heading, which is going to be text-5xl. So essentially incrementing all these by 1. We can just copy paste them and increment this to 5, this to 6, and the last one, large text, to 7xl. Also put a comma in the end, and the default variance we can leave like that. Great. And instead of the heading variance, instead of the paragraph variance, we want to pass the heading variance down here containing the size and the class name, and the rest looks pretty good. So I'm satisfied with this large heading component. We can save that, and by doing that we have 2 essential building blocks when it comes to the later stages of our application and building this whole thing out a bit easier. So now we have everything we need to get started with building the home page. So we can go to the main page.tsx, and inside of here we're gonna build this out. However, before we do that, I think it makes sense to get the layout right, because we are gonna be using certain fonts in this project and we want to use them throughout the whole application. We can close all the tabs that we don't need. We've already imported the globals.css, great. Some metadata, we can get rid of the metadata because we're gonna define that on the page layer. And also this import is not very pretty. We want the absolute imports, right? And to do that, we can go into our tsconfig.json, and that is gonna make the whole project way prettier. And we're gonna define some custom paths in here. We do that right here. And we want to define 5 paths in total. One is already defined. Then we want to define the @styles/anything and just pass that to source/styles/anything that we want. And essentially what we can do that by doing that, if I save that and go back into the layout, we can say @/styles/globals.css, and we can totally get rid of this whole dot and slash dot, whatever import naming convention. Just break out of that and use this prettier format for defining imports. Now, we don't only want that for the styles, we also want that for the @/lib/anything. That is gonna forward to source lib. Then we want the components, so @/components/anything is gonna pass the import to /source, /source/components/anything that we want. And the last one is gonna be @/UI/anything, and that is gonna go to /source/components/UI/whatever we want, and save that in our tsconfig. Now we're getting an error right here that the globals can't be resolved because we haven't put that into a styles folder. So we're gonna go into our app directory, create a folder called styles, and just put the globals right in there, and then the error should be gone in a second. Great. Now let's get this layout sorted out. It's a crucial component for the whole application. That's why this layout is super important. And we want to define only a couple of things in here. First thing we want to define is the font. So we're going to use inter for this project. So const inter is going to be equal to inter, and then subsets is going to be an array that takes Latin as an argument. And the inter comes from next/font/Google. We can import that. So import inter as a named import from next/font/Google. And this inter we can use in our HTML element right here, which is also going to use the very, very useful cn utility function that we've already defined. We can import that. That is going to be from @/lib/utils. That should be source lib. Oh, and the lib should be in the source directory, not in the app directory, and that goes for the styles as well. So let's move that into source, and that also goes for the components. So let's move them out too. There we go. So now these paths are actually working, and let's restart the, okay, VS Code seems to be loading right now, whatever. We can restart the Typescript server in a second. And for the HTML class name right here, we're going to call the very convenient utility function. And in here, we're going to pass some default styles. So background is going to be white. That goes for a whole page. Then the text is going to be slate 900 by default. We're going to apply some anti-aliasing, anti-aliased. There we go. And then to merge that with the font, we say inter.classname. And apparently the TypeScript server can be restarted now. Great, let's try that. And let's see if the import still throws an error or if that works. And we can close this, by the way. There we go. It seems like VS Code has some problems moving the components into the source directory. So let's save this really quick, exit the VS Code, and then move this manually so we can go into source and then components and then drag it out to similarity YouTube. Same goes for the lib and the style. Oh no, that should still be in the source. So component, they should be in the source, but they shouldn't be in the app directory. There we go. Okay, so at the source level, we have the app, the components, and the styles, and the lib. That's exactly what we want. So we can go back, open this back up in VS Code. Sometimes VS Code really isn't the best at doing that sort of stuff, but now it works just fine. And now let's finally get the layout sorted out. The body is going to receive a class name as well, and that is going to be a min height of screen. So it is going to take up a minimum height of 100 VH. That's the CSS that you can see if we hover over this. There's a background slate of 50 gonna be applied. So a very, very light blue, almost white-ish. You're gonna see that in dark mode. By the way, we declare dark mode differently. If we just put a dark colon in front of this, it's gonna be BG of slate of 900 and also anti-aliased. Format that using prettier. And great, this looks really good. Now let's do the groundwork, the foundation for the later project stuff. So in here, we're going to insert some components that we don't have yet. There's one going to be the providers. So we're going to be providing context to all the children in the whole document using these providers right here. Now this component doesn't exist yet, so we're going to create it. It's a very, very simple component that doesn't take long to do. So we're going to go into our components and then a new file called providers.tsx. Now I'm going to initialize this as a functional component, but if you don't have the snippet, then you could just write this out yourself. You could even leave this whole TypeScript part out because this provider is only going to receive one prop that we can also define inline if we wanted to. By the way, if you're wondering how to do that, we can do this like this. Children is going to be of type React Node. Like that. We can define this inline if we wanted to, but I kind of prefer the functional component approach. I think it's a bit easier to see, but this works just fine as well. Now this React Node essentially means we are receiving React components, like the children that we have right here are going to be passed as children to these providers. And because we're working in NextJS server and client component architecture, we're going to have to use the client director for this component, because if we want to provide context to different children in the application, we have to use client components for that. We cannot use those inside of server components. That's why we're declaring a separate client-side component for this. And we need two providers for this whole application. First is going to be the theme provider that we get from next-themes. So we're going to import the theme provider from next-themes, and this is going to allow us to do themes. This is going to allow us to do the beautiful light and dark mode throughout the application. It's super simple to use, and I really enjoy next themes. And then the second one, oh, by the way, we still want to pass two properties to this one, or three. The attribute, and I think my VS Code is still loading again. Sometimes it's a bit slow, but we can just type this out ourselves. It's going to be class, so we want a class-based strategy. The default theme for this is going to be system. So whatever the users are already using on their system, whether it's light or dark mode by default. And then we want to also enable system. There we go. And then the second provider is the session provider that we get from NextAuth. And also close that off because VS Code is slow as hell and it's still loading. Session provider. There we go. Now it finally loaded. And then in here, we're going to render the children. And that's all the providers we need for this application. Now, the session provider, we're going to use for client-side authentication in some components. Main authentication is obviously going to be server-side, but we do want this to use client-side authentication in some places because we have to. And we're going to import the session provider from next-auth/React. That's where we get it from, and that is our provider component done already. Now we can import it right here in the layout.tsx main root layout component that we have in our application. Great, we're gonna do one more thing at the end of the body, and that is, I'm gonna comment this in as well and change to German keyboard for this. Nope, that's not what I wanted to do, like that. We want to allow for more height on mobile devices. Because we're gonna have a very neat mobile menu, we want to render a self-closing div in here. And the only purpose this div has is to make some space at the end of the page so the mobile menu is a bit easier to access with a height of 40. And on medium devices and up, that is gonna be hidden. Great. And also inside of the providers, we want 3 more things. That is gonna be the navbar, a toaster, and a mobile menu. So let's just do that. This might seem a bit abstract right now that we're doing all this without seeing any results here on the right side, but it is really important for the later foundation of our application. So first one is gonna be the navbar. Now that navbar doesn't exist yet, so let's create it. And I promise you, with creating the navbar, we're gonna see the first results here on our actual page, and it's gonna be really cool. So let's create a navbar in our components. Let's create a new file called navbar.tsx. This navbar is gonna do a lot of stuff for us. If you take a look at the finished product that we're gonna build in the end, let me close that. This is gonna be the navbar. It has the main page, it has the dark mode toggle that we're gonna build, a link to the documentation page, and also a sign in button. So let's initialize the navbar as an FC component. And by the way, if you're getting annoyed that I'm using this FC all the time, you can do the same. If you go to File, Preferences, and then Configure User Snippets, and then let's go to Code Snippets right here. No, that wasn't the one. Preferences, Configure User Snippets, I think it's in here. It's this snippet right here. I'm gonna link it in the description. You can literally copy and paste it into your Typescript react.json, this FC snippet, and then you're gonna have the same snippet as I do. You can just type FC, press tab, and then have a full component in here, and it's gonna be really helpful and time saving. Okay, let's build this navbar. And now we're gonna really leverage the architecture of NextJS server-side components. So we're gonna declare this as an async component. And that means in here we can get the session of the user. So const session is going to be equal to await get server session that we get from NextAuth. Now we haven't configured NextAuth yet, so this doesn't make a whole lot of sense yet, but we're going to render the navbar conditionally, and the authentication is the next thing that we're going to do after building the homepage. So this is going to work buttery smooth here in a second. Now from this navbar, we want to return a div as a main component that we're returning with some class names. This is going to be fixed. If we take a look at the CSS equivalent, that is going to be position fixed. Then a backdrop dash blur of small to give us a nice blur effect in the background. A BG white / 75, and in dark mode that's going to be a BG slate 900. I'm going to make this full screen because this class name is going to be a bit larger. Then we want to give this a Z index of 50, a top 0, so it's always going to stay at the top, left 0, right 0, so it doesn't have any gaps on the sides. Then we want to give this a height of 20, a border on the bottom, a border of slate 300, and in dark mode that's going to be a border of slate 700, a shadow of small. We want to give it the flex attribute, so we're going to use display flex for this, which is going to allow us to have some control over how the children of this div are positioned. So we're going to say item center and justify between dash between, so the items are nicely spread apart in the navbar. And then let me move this div to the new line right here. No, I want it down here, please. There we go. And that is the long name of the navbar gone. Now the rest is going to be way easier. We're going to initialize a second div right here. The class name is going to be container. Now this container, we're going to create that right after writing out this class name. because right now or actually that is built into Tailwind, right? I forgot. Yeah, that is built in. We don't even need to configure that. This already works. This is going to be a container. It's going to make the mobile view way prettier. A max dash width of 7XL, which is I think 1200 and did I spell this wrong? Max. Oh yeah, this needs to be max dash W dash 7XL. That's why it didn't work. It's a max width of 80 rem. We want to give this an mx-auto to automatically be positioned in the center. Then a W of full, so full width, flex, justify between, and items center. Okay, there we go. We've created the div. Inside of the div, the first thing that we want is a link to the home page in the top left. So we're going to create that. It has an href. It's a component that we get from NextJS. It's super handy. Instead of having to use React Router, we're going to use file-based routing in NextJS 13, leverage the full benefits of that. And to do that, we're going to navigate using this link component that we get in NextJS. The class name of the link is going to be of button variants, and I think we didn't oh no, we don't have the button yet. That's another UI component that is super important that we're going to create right after. And the variant of this button variant is going to be of type link. There we go. So essentially we are going to create a link, but with the styles of a button. That's what these variants are for. And then we're going to say a text similarity 1.0 inside of this link component. Now let's do this component fully and then worry about all the stuff that we don't have yet. I think that makes more sense. Let's create a div right here with a class name of medium hidden. And this is going to take a theme toggle. That is the beautiful theme toggle. There we go. That is the beautiful toggle that we're going to create to adjust between light and dark mode. Then below that, we want another div like that with a class name of hidden medium flex. So this is only going to be for medium devices and up, and a gap of 4. So this theme toggle is going to be for the mobile view inside of this div. We also want the theme toggle. We want that on desktop too. We want a link component that we get from NextJS, the same as above, with an href of slash documentation, like that. This is going to get a class name of button variants as well. So we're going to import those here in a second. Button variants, and that is again to give this link the appearance of a button, even though it is not a button per se. That is going to be variants of ghost. So this is the ghost style button that we create up here, and if you click it, it actually looks like a button. That's what this right here is for. And this link is going to say documentation, because we're going to link the documentation page in there. And now we are going to differentiate between the session and if we don't have a session. So if we have a session, by the way, conditional rendering in React, we're going to use some curly brackets or curly braces and then differentiate between the session states that we determined up here. So if there is a session, then we're going to render the following. And if there is not a session, we're going to render something else, which is going to be a sign in button. So if the user is not signed in, we want to render a sign in button. And if they are signed in, we want to render something different. So we're going to have fragments in here. So we don't have to wrap what's about to come, which are going to be 2 children in a div, because that's kind of unnecessary. The fragment is just to do this without rendering another DOM node. The link is going to be in here with a class name of also button variants. Call that with a variant of ghost, variant ghost, to give this a ghost-like button appearance, this link. And then the href that this demands is going to be to slash dashboard. There we go. And inside of this link, we're going to say dashboard. This is going to link the user to the dashboard page. And then we also want a sign out button. Now these two don't exist yet. The theme toggle doesn't exist and the button variants don't exist yet either. The question is, which one do we get started with? And I think because the sign out and sign in button are very closely linked to the button component, it makes sense to start with the button first. We're going to create that the same as we did with the other components. under the UI, and then a button.tsx. Now this button is going to take a lot of properties, but it's going to be super useful across this whole application. So let's get started in creating this one. So I'm going to use the FC again to create a component, and let's define the variance first. You already know the drill. Let's call this button variance, and this is going to be a CVA. Again, and first thing the CVA takes, remember, is the default props that we want the button to have. This is going to be active of scale 95. So when we click it, it scales down a bit. It's going to be inline-flex, items-center, justify-center, rounded of medium. So a bit of border radius, just because it looks prettier. Can get rid of that. Rounded medium. Then text-small, font of medium, transition-color. So we get some Tailwind color transitions in this. Then a focus property of outline-none. Focus is going to be ring too, so we get some kind of outline when we click it. Also a focus of ring-slate-400. Focus of ring-offset-2. So there's going to be a bit of space between the button and the ring. That happens when we click it. And disabled, we want the opacity to be 50, so users can clearly see that the button is disabled, which makes for a better user experience. And then on dark mode, the focus is going to be ring-slate-400. In the disabled state, we want the pointer-events to be none, so there's no interaction possible with this button. In dark mode, we want and also focus, so if the user is in dark mode and just click the button, then we want the ring offset to be slate 900. So just adjust the dark mode color of that ring offset. And that is all the default styles that our button gets. And now we can actually get started in defining our variance. So let's put a comma here at the end and then pass an object that contains the variance property. Now you already know what we're doing right here. So first one is going to be the variant of the button. And in our case, we're going to have a default button, which is going to be background slate of 900. Text white, it's going to be with a hover state of background slate 800. A focus, now I got sucked into the GitHub Copilot suggestions. That's not what we want. So a text white, when we hover over this, is going to be background slate 800. In dark mode, the background is going to be slate 200. In dark mode, the text is going to be slate 900. And then when we're in dark and hover, then the background last property is going to be slate 100. And that is our default button. Now we can take a look at that very soon. At this button component, we also want, I think, 3 more. So first one being the outline. So whenever we want to have a nice complement to the default button, we can use the outline button, which is going to get a background of slate 900 as well, text of white, hover of bg-slate-900. In dark mode, that background is going to be slate 200. Also in dark mode, the text is going to be slate 900. And then when we're in dark and hover, then the background will change to slate 100. So bg-slate-100. The border is gonna, there is gonna be a border on here. The border is gonna be slate 200 in light mode. And if we hover over this outline button, then the background is gonna be slate 100. And in dark mode, the border is gonna be slate 700. Great. That's the outline button. We probably forgot a comma at the end of the previous one. Great. And then we also want to insert a comma right here. And now for the ghost button. Ghost variant of this button is going to be a BG of transparent. So at first you're not going to be even to tell that this is a regular button, but it's going to have all the best accessibility implementation. So when you use keyboard navigation, for example, it's still recognized as a button. It's just not visually immediately obvious because that's what we want to happen. Then in hover, a BG of slate 100, dark mode and hover, a background of slate -800. In dark mode, the text is going to be slate 400. And if we have a data of, and then in these array signs right here, if we have a state of equals to open, so state equal to open, then the BG is going to be transparent as well. If we're in dark mode and have a data dash state is equal to open, then the BG is going to be transparent. So no matter if we're in dark mode or in light mode, the background, we're enforcing it to be transparent for this ghost button. And then the last variant that we want to have is the link variant we can use for links. This is also going to get a BG of transparent. In dark mode, the BG is going to be transparent as well. We want an underline and we want an underline offset to be 4. So that means when we underline this link, the underline that we have is not going to be immediately below the text, but it's going to have a little offset, so it looks a bit prettier. When we hover over this, the underline should appear. We want a text slate of 900. That's going to be the default text color, pretty dark. And then when we're in dark mode, it's going to be the opposite. It's going to be very light. So in dark, the text is going to be -slate -100. When we hover over this, the BG, the background, will stay transparent. And when we're in dark mode and hover, the background will also be transparent. Great, that was the exhausting part of the button done. Now we can move on with the sizes. They're going to be a bit more enjoyable to write. So size, it's going to have 3 different sizes. One is going to be the default, that we want to pass a height of 10, padding y of 2, and a padding x of 4. Then the small variant is going to get a height of 9, so just a bit less, height -9, no comma there, then a padding x of 2, and a rounded of medium. And then the large variant of this button is going to get a height of 11, padding x of 8, and also a rounded -medium. And now let's finally define the, nope, not like that. Let's define the default variants. So default variants, gonna be very easy. Variant is gonna be default. And then the size is also gonna be the default size that we've defined right here, and the default variant up here. Great, and that's the button variants done. Now you already know the drill on the rest, so we can just get the interface, extend that. And the reason we're doing that, I explained it previously, because first we want to get all the attributes that a button could normally get wherever we render this component, so we can pass them on. We do that by extending the interface with the button HTML attributes, and then here we can pass the HTML button element like that. And then again, we also want to extend this by the variant props with the type of button variant, so we can pass the size and the variant of this button wherever we render it. Great. And then one final thing, we want this button to have a isLoading property, which is going to be an optional Boolean value, and we can pass to this button if we want to. Okay, again, we're going to do the forward ref thing. So if we wanted to, we could pass a ref to this button component from the parent wherever we render this. And if we don't want to, then that's totally fine as well. That will work just fine. The forward ref takes 2 arguments. So first one being the HTML button element that we're trying to render out here. And then second one being the button props that we've defined up here, to let Typescript know what the props are that we can receive and destructure right here. And we're going to destructure the class name from this component. We're also going to destructure the children, the variant of the button, the isLoading custom property that we've implemented up here, the size of the button, and then everything else we will receive as the ... props. So that's a catch-all for everything else that is passed. And then as the second parameter or argument, we can receive the ref of type forwarded ref HTML button element, but the type is automatically inferred, and we don't need to worry about that. And then to finalize our component, we're going to render out the actual button. And this button is going to get a class name of the cn utility function to conditionally merge these classes together of type button variants. And then here, whatever is passed as the props, we're going to just pass in here. So that's going to be the variant, the size, and then also the class name. If we want to change that from wherever we render this button, then we can have the ref in the button, so a link to this DOM node of the button. The disabled property is going to be isLoading. So whenever this button is loading, it's also going to be disabled. So the users can't click it again, which would make no sense. Then we want to pass all the other props that we have received right into this button component. And inside of the button, we're going to have two things. First, it's going to be the children. And then secondly, what also makes sense to have in here is the isLoading. And if it is loading, then we want to have a loader 2 that we get from Lucid React, and it's not showing the proper import right here. So let's import this manually. Import loader 2 from Lucid-React, which is the beautiful icon we're going to use as the loader. This is going to get a class name of margin right 2, height of 4, width of 4, and then an animate-spin. So this loader spins by default, that we get from Tailwind already, which is super convenient. And then else, we're going to render out null. So if this is not loading, then we're also not going to show any spinner. Great, that's our button done. Last thing we want is the display name of this button. And that is going to be equal to button, just for debugging purposes if we ever need that. And what we can do now is import these button variants that we, by the way, also need to export from the button component inside of a navbar, like that. Then the variant should be not variants, but variant. The theme toggle we still don't have. And now it's going to be super easy to create the sign in and sign out button. Let's get started with the sign in button. We're going to create that under components, sign in button.tsx. And that is going to be the link to the Google login, which is going to be super convenient. And inside of the sign in button, first thing we're going to do is initialize this as a client component, because we're going to use an on-click handler on the button. And if we do, this has to be a client component, because server components cannot utilize that kind of interactivity. Then let's initialize this as an FC. You already know how to create a snippet. And then here, let's handle the sign in button logic. So one thing we want to have inside of this button is a state. So we can say state, or if you don't have a snippet for that, we can write the state ourselves. It's going to be called it's loading and is loading, and then set is loading is going to be equal to use state, which we can import from React, and the default is going to be false. Now, if you're in Typescript, we could explicitly type this out as Boolean, so we couldn't change it later without it alerting us that any values that depend on this state right here would also need to be modified. So I just like to do that. Okay. Then we're going to create the actual button right down here. And for that, we're going to create or use the super reusable button component that we've just done in the UI. The button is going to say sign in, and on click, a function is going to be called that we're going to call sign in with Google, and then is loading of is loading. And that is going to be equal to. So whenever this state is true, we're going to pass it on as the isLoading property to the button component. Now, the sign in with Google function doesn't exist yet. So we're going to say const sign in with Google is going to be equal to an async function that we're going to use to handle the sign in logic in the sign in button. And for that, we're going to use this state. So first thing we do when we call this function right here is set the isLoading to true. And I am going to disable GitHub Copilot for this because it is getting kind of annoying. And then we want to have a try catch block in here because we're going to handle some async logic. So what we want to happen is to wait the sign in function that we get from nextauth/react. It's super convenient. And then here we can pass the Google provider, because that's what we're going to use to allow users to log into this application. And if this goes wrong for some reason, we want to have a toast notification that we're also going to create together. Toast, and that toast is going to get a title of error signing in. Then it's going to get a message of please try again later or anything that you want as a message. And the type of this toast notification is going to be of type error. And that is the sign in button done. Now we would be signed in to Google if we just had the toast notification. But let's save that for now. Let's accept that it doesn't exist yet and import the sign in button. And we don't want that from dot, but from add/components/sign in button. And same goes for the button variants that we want from add/UI. It's just a bit prettier having those as the imports. And then the sign out button is going to be very similar. And the reason we have these as, oh, by the way, let's create the sign out button.tsx. And the reason we have these as separate components, instead of just having one button with and passing it the function that it should execute, is because you cannot render the client-side components from a server component like the navbar and pass it a function directly. That doesn't work. So we're the only two unreusable components, or I guess they're not really unreusable, but modifiable components are going to be these buttons right here. So we're just going to copy paste the sign in button, call it sign out button, and reuse that naming across this component. So we want it right here. We also want it for the props, and that is going to be fc of sign out button props. Now the logic is going to be very similar, slightly different, however. So instead of awaiting the sign in, we're going to await the sign out that we also get from NextAuth by default. And then, just change this to error signing out. Please try again later. And also change this to sign out. And we could also change the name of the function. Let's call this sign user out. It's just a bit more fitting to what we're actually trying to do. Now for both of these buttons, the toast doesn't exist yet, but we're going to worry about creating that here in a second. For now, we can already import the sign out button right here from add/components/sign out button. Great. Now there's two things missing currently. That is the theme toggle and also the toast notification. And they're not too much work, so I think we can get started on them right now. Now, before we do that though, I think it's always important to live see what you're even building instead of just typing along with what I'm typing. So let's comment this theme toggle out for now. And also these toast notifications. And let's see what we have built so far. Let's just comment them out. In the layout, the navbar, we still need to import that, and that is going to give us an error because we are using the navbar as a server-side component that uses an async right here. So we also, by the way, we can remove the props. We are not going to get any props for the navbar. We need to expect this error. The NextJS team is currently working with Typescript to resolve this, but for now we need to say add ts-expect-error and then server component. Now the server component is completely optional. You don't have to have this in there, but I just still do it so you know why we are expecting this error. And if we save that and go to the browser like that, we can see what we're building in the local host. And that is not the application just yet. Let me see, is the server started? Okay, so the server isn't even started. Let's start up the server using yarn dev or npm run dev if you're using npm. And let us restart the localhost 3000 and take a look at what we have built so far. You can close that down, let it load, give it a second. And then this is our navbar. Great, we can see on the right hand side, there is the documentation and there is the sign in button that we can use. And these actually already work, at least the documentation. Now the sign in button doesn't work perfectly just yet because we haven't done the whole authentication, but we're gonna do that. But first, let's finish up the navbar with the theme toggle. And I think that was all we need to do to finish up the navbar, right? So let's insert the theme toggle right here. That is going to allow us to switch between dark and light mode. It's going to look really, really good. And let's go into the theme toggle. So let me move this a bit to the side again. Let's create a new component called theme toggle.tsx. Initialize that as an FC. And now we can get started building out the theme toggle. Now let's think about the functionality that this theme toggle would have to do. And the most important thing is change the theme, the underlying theme, right? And to do that, we're going to import the set theme from use theme, which is a hook we get from next-themes. That is why we're using this package. It allows us to change the whole theme of the application super easily with this simple hook. Now, because we're using a hook, that also means we have to use the client-side rendering tactic for this theme toggle. Otherwise, we couldn't use a hook. Now, to build out this theme toggle, we are using a radix primitive. So if I go to radix drop-down menu, you can see that we're using the drop-down menu from radix, which is an unstyled drop-down menu that exposes a bunch of really handy stuff like the trigger, the content, the portal. It handles all the logic that is needed for a drop-down menu for us without dictating any of the styles. However, I think it would be very tedious for you to type this out yourself to do the whole drop-down component. So I suggest that you go over to the similarity GitHub that I made and go into the source folder, into the components, the UI folder, and then into the drop-down menu.tsx and just copy these 200 lines of code right here. That might seem a bit unintuitive at first, but don't worry if you understand exactly what is going on in this logic right here. Because essentially what we're doing in this logic is the same thing that we've already done, right? The forward ref, we're passing it a bit of types, and it is just easier to copy and paste this if you're not familiar with TypeScript. You could rewrite this in JavaScript if you wanted to, but essentially we are getting the unstyled stuff from Radix, styling this ourselves with some Tailwind classes, and I don't think it would be worth our time to code this out ourselves. So just copy and paste this into our drop-down menu that we are going to create right now inside of the UI folder. Call this drop-down menu.tsx and paste the file that we have just copied from GitHub. Now, if we take a look at this, we are importing, for example, the root and the trigger and the group, all from Radix UI/React drop-down menu. And then we can do whatever we want in styling this. But as I said earlier, it's not really worth worrying about, even if you don't understand exactly what is going on. You're gonna see why we're doing this right now. And that is to build this theme toggle right here. It's gonna be super easy using this component. So because we just did this, we can import the drop-down menu from add/UI/dropdown menu. We can close all the other stuff, by the way. We don't need that right now, it just clogs up the view a bit. And the convenient thing is now we can work with this, with the first thing being the drop-down menu trigger. So when we click this, or the children of the drop-down menu trigger, then the drop-down menu is going to be activated. And we also want to render this as child, which is an option that Radix UI exposes to us, because we want to render a button in here. So we can customize the style of the button. If we didn't have this as child directive, this would be a button already by default, and then passing another button into the button would lead to a hydration error, which we want to avoid. The variant of this button is gonna be ghost. This is the button we defined ourselves, and the size is gonna be small. We don't want this theme toggle to be huge. And then inside of here, we want the sun from Lucid React, just the icon. Give that a class name of rotate-0, scale of 100, transition-all. So we're preparing this to be animated really nicely. If you take a look at the final product, we can see that if we change the mode, there's actually a little spin there. It's a really, really nice and smooth transition. That's what we're doing with these classes right here. If we hover over this, we want the text to be slate 900. And if we are in dark mode, we want the minus rotate-90. So rotate is in a negative direction by 90 degrees. If we are in dark mode, the scale is going to be 0. And then also if we're in dark mode, the text is going to be slate 400. So that's going to be the text color. And if we're in dark mode and hover over this element, this icon, then the text is going to be slate 100. Great. Then we don't only want the sun, we also want the moon for the dark mode, right? It just makes sense. So we're going to import the moon also from Lucid React, pass this a class name of absolute. So we're gonna rip it out of the normal styling of CSS and put it in an absolute position. Rotate it by 90 degrees with a scale of 0. Then a transition also. Every animation we apply to this is going to be smooth. When we hover over this, we want the text to be slate 900. And when we are in dark mode, then we want to rotate this to 0. So rotate -0. When we're in dark mode, we want the scale to be 100. When we're in dark mode, we want the text to be slate 400. And then when we're in dark mode, last property that we're going to pass, I promise, at least for this moon, is going to be hover and text dash slate dash 100. So let's take a look at the theme toggle for now. We can just save this, import the theme toggle. Now there's still a bit of stuff left for this theme toggle, but as I said earlier, I want you to see what we're building while we are building it. It doesn't do this. Let's move this over. Go to localhost 3000, and as you can see, the theme toggle is right here. Now it doesn't do too much yet if we click it, but we can see the moon because we are in dark mode. Now, as an accessibility best practice, what we want to do is also include a span right here, and then give this a class name of sr-only. What this means is screen reader only, so it's essentially hidden, but screen readers will be able to tell the contents of this. And so for people who are visually impaired, for example, that need to have screen readers, we're going to include this and say toggle theme so that they can also navigate the website without any problems. And that is the drop-down menu trigger done. That is this icon we've created up here. And now we want the content, right? So what happens when we open this drop-down menu? For that, we're going to render the drop-down menu content. It also comes from the component that we've just done, the drop-down menu. And in here, we're going to have a drop-down menu item from the same component. Okay, the content should have two properties. That is going to be align end and also force mount. Used to force mounting when more control is needed, useful when controlling animation, which we want to do with React animation libraries. Exactly. And then the item, what are we going to do in here? It's going to get two things. First, the sun that we already imported from Lucid React with a class name of margin right of 2, a height of 4, and a width of 4. That is going to be self-closing. So whenever we click the sun, what should happen? Well, whenever we click the sun, what should happen? It makes sense to set theme to light, right? When we click the sun, that should happen. And let's include a span right here that says light, just to inform the users what they're about to click. And then as the second menu item, we can actually just copy paste this. I think that saves us a bit of time. We're going to do the same thing for dark. Obviously, we want to set the theme to dark mode and render the moon instead of the sun. And then as the last menu item, we're going to copy paste this again. We're going to set the theme to system as the third option. Now this is going to be the laptop icon. You can choose whatever icon you like. And let's say system in here. There we go. And just like that, we've built a super clean component that we can use to switch between light and dark mode. Now, I think one reason why this doesn't work yet is because we also need to configure one more thing in our Tailwind config. And that is for, I'm not sure how this is called. Let me look this up. Tailwind config. It's called dark mode, like that. And we're going to pass that in array that receives the class values. That means we are using the class strategy to render or dark mode. And that did not compile because Typescript doesn't check this. We also need to include a comma right here. It's a bit intransparent. Okay, so we have the dark mode as class in here. And now let's try if it works. And yes, it does. Beautiful. So now we can use the theme toggle to go between light and dark mode and the system. And essentially what this does is, let me show you what this class mode even does. So when we go into the elements and zoom in a bit, we can see that we're in dark mode right now. And pay attention to this HTML right here. If you go to light mode, you can see the color scheme changes to light, and there's also a light class applied to the HTML. If we go back to dark, that light changes to the dark class. So that is how every component in our application, or every div, every button knows which mode we are currently in. That's how Tailwind CSS works under the hood. And by the way, while we are in this Tailwind config, we can define just a bit more stuff. So for example, we're going to extend the theme by a container. So we're going to say container. That is going to apply to the container class that you already saw earlier. We're going to say center true. We're going to say padding of 1.5 rem. And the reason we're doing this is just to unify the styling across our application. That is why we're configuring this container. And then screens is going to be an object where 2xl is going to get a 1360 pixel value. Great, and that is everything we're going to extend the container by. And now let's extend the default Tailwind theme. It's going to be 2 properties. It's not much. First, the font family. We want to use the inter font. So we're going to say sans or sans. I don't know how to pronounce it, but it's going to take an array that has a string in it with var and then -- font -inter to make sure we're using the inter font. Then spread in the font family.sans. Now, where do we get this font family from? We get this from an import from the Tailwind default theme. So we can say const family, no, that should be font family. It's going to be equal to require, and then Tailwind CSS / default theme. There we go. We can save that. And then the second thing we want to extend our Tailwind config by is by colors. So that is for the main gold color that you saw in the page. When I show you that again, it's this gold color right here. We want to define that in our Tailwind config. And we do that by spreading in all the default Tailwind colors. And then we want the light -gold to have a value of hashtag and then F5 BC51 as a hex value, and also the dark -gold to have a hex value of hashtag 533519. Now the default colors we don't get like that. We also need to import those from the Tailwind colors. So we're going to say, as another import, const colors is going to be equal to require, and then Tailwind CSS / colors. Great, that's where we get the colors from. Now you can see it changed from any type to import colors, so we know it's working. And then the last thing we're going to change in the Tailwind config is the plugins configuration. We're going to use 2 plugins in this project. First one is going to be require Tailwind CSS -animate, and then the second one is going to be require add Tailwind CSS / typography, like that. Let me expand this a bit. These are both development dependencies that we have not installed yet. So once more, let's open up the terminal. Let's pause the app for a second, and then say yarn add or npm install -d for development dependency. And then we want the Tailwind CSS -animate, paste that in here. Also add Tailwind CSS / typography, also paste it in here, and install those as development dependencies. Now the reason we're installing those as development dependencies is because we don't need them in production. They shouldn't be used in a production setting. They are just for local development. Okay, and one reason we just installed those is so we can configure one more reusable UI component that we're going to use in a lot of places across our application, and that is going to be the toast.tsx. Now the toast notifications, if you don't know what those are little notifications that notify you of errors or of successful changes or whatever. They make for a way better user experience. And to leverage the power of these toast components, I think it makes sense to go into the GitHub once more, and I think one last time, and go into the UI and then go to toast down here. You can see this is a bunch of lines of code that I don't think it makes too much sense writing this out ourselves. What we're doing is we are creating the base code from React Hot Toast and then extending that code with our custom toast notifications. So I think it makes sense to go in here, copy this whole code that handles the toast notifications for us, and paste it into our toast.tsx component. Now there are two errors right now. First one being the icons, but we can get rid of that. And then the toast icon props. To fix the icon error, we're going to define a separate component for the icons called just icons.tsx. This component is not even going to be a functional component. It's just going to be an export const icons, and that is going to be equal to an object. And here we're going to export the chevron left. And we get all of these from Lucid React, by the way, but the auto import doesn't seem to work. So we're going to say import chevron left from Lucid-React. We're going to also want the chevron right, then the sun, the moon, and the laptop. And we're going to switch those out to where we already use them in the theme toggle. We want to import all of those, chevron right, the sun, the moon, and the laptop from Lucid React. And then export these icons as default. Export default icons. Like that. And now for the components in here, we can prefix this with icons. So if we decide to change the icon later, we can do it in one place. We're just going to make this a ton easier to manage. And that is our toast notification error gone as well. We can just save the toast. And now to enable toast notifications on our application, we need to go into our root layout and define the toaster in here. So we can say toaster, import that from the component we just created. That allows us to render the toasts in the root level of our application. And then the position property is the only one we're going to pass to that. You can see there's a bunch of options, but we want to choose the bottom right, but you can choose whatever you want. You could go with the bottom center, top left, whatever you want, but I prefer the bottom right approach. There we go. We can save that toaster, and now we can use the toast notifications. And I think it was in the sign in and the sign out buttons where we left it out earlier. Now we can uncomment that and import the toast in the sign in button and also in the sign out button. Comment this in again, import the toast notification, and let's see if it works. Let's save all the components, go into a split screen mode, and then to our local host. I think this is not proper split screen. There we go. The server should still be running. It is. Let's restart this and take a look at the application. Actually, I can go just full screen. That's a bit easier to see. And we get a hydration error. No, never mind. We don't get it. Let me refresh again. No, we don't get it. Okay. And now we can click on the sign in. Let's see what happens. And great, we did get forwarded. Now we didn't implement the authentication yet, but this is where the toast notifications would appear. So we can actually just mock this for now. We can go into our navbar and let's say we clicked on the sign in button. Instead of awaiting the actual sign in, let's just do a toast notification instead. We're gonna change this back in a second just to check if the toast notifications are working, and they are working. Great, you could see the toast notification there in the corner. So let's move this back into the cache where it actually belongs. And there we go. Now we made sure that toast notifications are working. Great. Okay, just to summarize until this point of the video, we have made some massive progress. We have implemented the light and dark mode toggle. We've implemented toast notifications and a really good looking and fully responsive navbar. Good work if you're following along. Good work. And we are not going to slow down. We're going to plow right ahead. We can close everything that we have until now. Let's get started on the main page and style that. Because that is really important when users get to our application. They want to see something beautiful. And this page is going to be really straightforward. The first thing that we want to do is import the metadata, I think it's called, type. So we can say type metadata from, and then in quotes, next, so that we can now define the metadata for this page. It's going to be metadata of type metadata that we have just imported. That is going to be equal to an object. And here there's a bunch of properties that we can pass. And this is the beauty of Typescript, by the way. We can see what we can pass to this, but we only want to define the title as similarity API home. and then the description of free and open dash source text similarity API. And if we save that, we can see what happens. Instead of localhost 3000, it says similarity API home on our website. That's what we just did. And now let's get started in styling this page. It's not going to be a huge component, so this is pretty straightforward. Let's start with creating a div that is going to get a class name of position relative, height of screen. So that's going to be a 100 view height in regular CSS. It's going to be a flex, item center, justify dash center. And let's go into full screen for these class names. And then an overflow x of hidden. Okay, now in here we're going to have a div called container with a padding top of 32 to offset the navbar height, and then add some, because remember the navbar is 20, we set a height of 20 and we offset that by 12 additional units. And then a max width of 7XL, MX auto to put this in the center, and then also a width of full, so it's always the maximum width that we've just defined right here, and then a full height. Inside of this div comes one last div, I should say, with a class name of height of full, a gap of 6, flex column, justify dash start. In the large screens, that's going to be a justify dash center with an items of center. And on large devices, we want the items to be at the start, so large items dash start. So we're going to differentiate between the devices, make this nicely responsive. And in here, we're going to render a large heading. Now the import doesn't seem to work. I don't know why, but we can import that ourselves. Import large heading from @components/UI/large heading. And that is not a named export, but that should be a default. Like that, we can access the large heading. Inside of here, we're going to define the size of this heading, which is going to be large. Then we want the class name to have a very specific class name that we're not going to reuse, but this is going to make this gold and 3D, what you can see right here. That's the effect we're going for. So we're going to call this 3-D, which is a class we're going to define here in a second. Text black. And in dark mode, the text is going to be light dash gold. Now for this 3D, let's quickly go into our globals.css and do a quick extension. So we want to say .dark .3D. So when we're in dark mode, then the 3D should be a text dash shadow of 0 pixels, 5 pixels down, and then 0 pixels, I think it's to the side, the last one. And then of hashtag 533519. That's the hex value we're using for this. And then for the normal 3D in light mode, we're going to apply a text dash shadow of none. We don't want any in light mode. There we go, save that. And now this class gets recognized. And as the main heading for our application, we're going to say easily determine a little break here. So this looks nicer. Text similarity. Let's take a look at what that looks like in split screen. Let's go to our local host. Okay, great. We've got the easily determined text similarity. Let me change this into a nicer split screen mode. There we go. And now we can continue with a paragraph that kind of explains what we're doing. Let's give this paragraph a class name of max with XL and then large text dash left. Inside of the paragraph, we're going to say with the text, or let's make this lowercase, with the text similarity API, you can easily determine the similarity, let's format this, between two pieces of text with a free, let's insert a JavaScript space here. So there's always going to be a space, and that is not going to be affected by the layout, because right now we're going to include a link right here that we get from next link. The href is going to be to /login. And we also want to pass a class name to this link, which is going to be underline underline offset 2, and then text dash black, and in dark mode the text is gonna be light gold. Great. And let's give this a bit more space that we can work with. And inside of the link that we have just created, we want to say API key and also a dot after that. So if we save that, we can see on the right hand side, we can see the text right here, and then a link to the login page if the user wants to get their API key right away. Okay, this already looks really good and is fully responsive. Let's continue. After the link, we're gonna have the last thing for this component, which is gonna be a div that has a class name of relative width of full. This is gonna contain the image later. A max width of large. On large screens, the max width is gonna increase to 3XL. On large screens, it's gonna be left 1/2. An aspect of square, because the image we're gonna provide to this is gonna be a square. On large screens, the position is gonna be absolute. And that's it. That's all the class names we're gonna be applying to this div. And inside of this div, we are gonna contain the image component from NextImage, which is a really handy component that does the image optimization for us. Super convenient. And here we're gonna pass the priority tag, because this is gonna be our largest contentful paint. And generally you want to preload that when using when loading the website. It's gonna improve your core web vitals as well. We're gonna apply a class name of image-shadow, which we're gonna create in our globals.css. A quality of 100. This should look great. Users should be able to see the full quality of this. A style of, we do this in these double curly braces, object fits of contain. Then a fill, so it fills whatever parent it has, which would be this div right here. That's why we gave this so many class names. A source of /type writer.png, and then an alt of type writer. Now, if you don't know where this image is coming from, it's also in the GitHub repository. Don't worry about that. Go into the GitHub repo, and then if you go back to the root of the project, you can go into the public folder and then see the typewriter.png. I might scale this down for the final version because this is a huge image and I think it's not necessary to be this big, so I might scale it down a bit, but essentially it's the main picture that we're showing here on the homepage. So let's go back into the split screen like this, and also put the image in the public folder. So into source, and then, oh no, that's not in source, that's in public right here. I'm gonna just grab the image off of the other project I've got open right here, go into public, and then drag over the typewriter, copy it in here, but you would download it from the GitHub repository and put it as typewriter.png in your public folder. Okay, let's reload the local host, and now we can see that the image appears. It's gonna be fully responsive depending on the kind of device you're in. It's gonna be downscaled automatically in quality, so it always loads very fast, which NextJS does for us with this image component that we rendered it in. Super convenient, and congratulations, that's the homepage done. First page of this project successfully done. Good work, really, really nice. And now we can get started on the other pages. So for example, the dashboard or the documentation page, depending on which one you want to complete first. And first, let's start with the documentation page. I heard you screaming, Josh, let's start with the documentation page, and that's fine. We can go into the documentation, and let's get started on that. So currently, when we click on documentation, we get forwarded to a site that doesn't exist, and we don't want that to happen. So we want to create a new folder in the source app that is going to be called, let's have a route segment here. So let's put this in these parentheses, I think they're called, docs. So what this means is that it won't be reflected in the URL structure in the end. So if we were to go to localhost 3000/docs, nothing would happen, but it is for internal management. It looks a bit cleaner. And here, let's say documentation, the folder So we created an actual path for this with a page.tsx that's going to contain the content for our documentation page. So if you were to navigate to the documentation now, this page would actually get rendered, and now we can get started coding out this page. And the root level of this page is going to be really simple actually. We don't need any props, so we can remove those from the functional component and then worry about the metadata first. So again, we're going to import the metadata type like that from next. Now we can define the metadata for this particular page. That's why we're doing this. Export const metadata as metadata type that we've imported. And we're going to say as the title, similarity API, and then a pipe and documentation. So the user knows where they currently are if they just see the tab. Then a description of free and open source text similarity API. Great, that's the metadata done. For the actual page, we want to pass this div a class name of container, maximum width of 7XL, a margin X of auto, and a margin top of 12. Inside of this div is going to be a div with a class name of flex column item center. So if you assign the flex column property, then the item center and justify center actually switch around. So now if we want to justify center with a normal flex, in the flex column mode, we have to use the item center. And let's give it a small gap of 6. And inside here, there's going to be a large heading that for some reason it doesn't give us the import option, but we know where to get it from because we created that large heading. And then from add/components/UI/large heading. And I think we can actually leave out the components because we have just the UI, and that is not going to be a named import. I did that wrong again, but a default one. Okay, and let's say making a request instead of this large heading. Let's save that, see what happens. And okay, so this is kind of clipped. To fix that, let's create a layout for all pages in here. Layout. Now we do get an error for this, but this is going to be fixed in a second. We want to export default function layout from right here. That receives an object with children. And these children, if you're working in TypeScript, we also want to define the type of, which are going to be react.reactNode. That's the type of the children we are receiving. And this layout function is just going to return a section. And this section receives one class name, which is of padding top 20 to offset the height of the navbar. That's why we're having this padding. And inside of here, let's just render the children. Save that, reload the page. And now we can see making a request is being rendered out properly. It's not clipped and looking just as it should. Okay, and now let's go with the paragraph in here and say API/view1/similarity, because that's what the path for this endpoint is going to be. Save that. And why is that being rendered out so large? That shouldn't happen. Did I mess up the paragraph stylings? And I don't know why it imported the paragraph from UI large heading, but this should be from paragraph. And that's why it's looking so weird. And now it's rendering the paragraph properly. Okay, there we go. And we want to have one last component for this page, which is going to be the code to show. And we will call that documentation tabs. Now this component doesn't exist yet, so let's create it in the components folder, new file, documentation tabs.tsx. Let's initialize this as a functional component. We can remove the props because this won't receive any props. Also get rid of this. In turn, save that, and now we can import the documentation tabs right here. Now that won't show anything yet, but we will be able to see that something will follow right here, the documentation tabs. Okay, now to get started with the documentation tabs, so let's move that over. We don't need that right now. Let's go into the component, and I think there's one more component we need to get from the GitHub, but then that should really be it, I believe. And this is a very simple component. Doesn't add any new functionality that you don't know yet. So I think it's fine to copy it over, and we get it from the source directory, navigate into there. And then when we go into components and then UI, you can see there is a component called tabs. This is what we want. We define two radix primitives, or rather we import radix primitives and then define the styling ourselves in this component right here. And they are really beautiful tabs that we can then use. So in the finished version, these are the tabs that we can use. They look great. And that is what this component is for. It's 55 lines of code that we don't need to write ourselves. So we can go into this GitHub repository. It's a client component. We can go back over to our documentation tabs. And this is not where we're going to paste it. Instead, we're going to paste it in the UI folder as a reusable tabs component. So we can name this tabs.tsx, paste the code in here. And there is not even a Radix UI that we still need to install because we've already installed the Radix UI /React tabs that this uses under the hood. And now we're golden. With these tabs in place, we can get started building out the documentation tabs. And the layout of this is going to be super intuitive now that we've got the tabs component. If we take one closer look, we can see we've got the tabs list. There is a tabs trigger. So that would be what is at the top that the user actually clicks. And we've got the tabs content, and that is it. This really makes sense. It's a logical structure of this component, and now let's use it in our documentation tabs. So at the root level, we want the tabs that we get from the UI/tabs. That is gonna contain all the logic for this component. Inside of these tabs, we're gonna render a tabs list that we also get from the same component. And this tabs list takes two things, or however many you want to pass, but in our case, that's going to be two things. That's going to be the tab triggers. So tabs trigger that we get from the same component again. And we want to have two code snippets, right? We want to have one for Node.js, and the second one should be for Python. Now these are kind of complaining because Typescript knows that they're still expecting a value, and that value is called value. And what is this value exactly? What should we pass in there? Well, we can define the default value we want at the tabs level, at the top level. And in our case, that's going to be Node.js. So this would mean which code do we want to show by default? And then we can give this an additional class name of a max width of 2xl and a width of full, meaning it's always filling out this max width that we just gave it, because that makes it look a bit better on the front end. And then for the tabs trigger, and here we can pass as the value Node.js. And then for the Python, you can probably imagine what we're going to pass. It's going to be the Python. There we go. And then we want to render the content, right? This would be, if I show you what this looks like, let's move this over into a split screen again. And sometimes that's a bit unintuitive. There we go. We want to have this open on the side. And these are the tabs. That's what we just created. We've got the Node.js and the Python. However, these don't do much yet. And now we're going to create the content in each of these. And the content is going to be in the tabs content, as you might imagine. Now the value for this tabs content is going to be Node.js. And then we also want to create one for Python. So what should be shown if this tabs trigger is active versus what should be shown when the Node.js tabs trigger is active. And that's what we define in this tabs content right here. Inside of here, we're going to do some cool stuff. So first off, we're going to render a simple bar. And I think, yeah, that doesn't give us an auto import. But we know where to get this because we did the dependency installation ourselves. So we can import simple bar from, we got a package for that, simple bar React. Actually, you know what? We're going to put that on hold. I think it makes more sense if we go with the main code component first. That's going to be shown for the documentation. And then I'm going to show you how the simple bar adds to that in a really beautiful fashion. But just for your understanding, I think it's easier if we first do the code component. Okay, now this code component is a component that doesn't exist yet. We still need to create that. And we're going to create it right here in the components folder, call that code.tsx. And this is a component I've already done a tutorial on my channel. It's a super beautiful component to do animated code. And we are going to do what I went through in that video to create this beautiful animation effect that you can see right here. If we go over to Node.js, this animation right here, that is being handled by the code component and then everything else by the tab component. Okay, now to recreate that right here locally, first we're going to initialize this as a functional component. You know how to do this by now, a TypeScript component, super helpful snippet to do that. And then we want to add some stuff to the interface. So define the type of the props that we're going to receive for this code component. First, we want the code that is going to be passed as a string. That is going to be the actual code that's rendered out. Then we want to know whether we want to show this component or not. So if we are on the Node.js tab, for example, we don't want to show the Python code, then the language, and that is going to be of type language. Now that is a type that we can import. Yeah, I don't know why these auto imports are not working. That is kind of not very helpful, but we can import this type language from Prism React Renderer. That's where we can get this type from. Essentially meaning if I hover over this, the languages that are supported for the syntax highlighting that we're going to implement in this. So there's a bunch of languages in here, most notably JavaScript, TypeScript, and Python that we will profit from. And then we want two optional properties. First one is going to be the animation delay of type number. And then the second one is going to be whether we want this to be animated or not. And obviously that is going to be a Boolean. And now that we've defined the code props up here, we already know which props we can receive in this component, meaning we can destructure them very easily hitting Control and Spacebar to know which props we can destructure in this component. So that's going to be the code, the language, show, animated, and lastly the animation delay. The code that we want to render out, we're going to keep in a state. So let's write out the state ourselves. I think it's easier for you to follow along. We're going to call this text, and set text is going to be equal to use state. And that is going to be the animated if we decide to pass that as the props. And if we do decide that this code should be animated, then we want to render nothing as the initial text, and else we want to render the code. So if it's not animated, we can show the whole code right away. And we also want to get the theme from our current, like the theme that is currently active in the application, to later use that for the styling of the highlighting. And we do that, you might know this already with the use theme hook that we've used previously. And in here we can destructure the current active theme, and let's call that application theme, like that, and format that using prettier. Great. And let's get started on the logic for the actual code animation. And to do that, we are going to use a use effect. And by the way, because we're using these hooks, use state, use effect, we need to declare this component as a client component in order to allow for that interactivity. This use effect, we are going to initialize with an empty dependency array. We're going to add to that here in a second. And then if we want to show this component and the component is animated, then the following is going to happen, right? If we don't want it animated, we don't bother with the animation implementation that we're going to do right now. First off, we're going to have an index. So let I is equal to 0. And then we're going to set a timeout. The timeout receives a callback function. And either if we pass an animation delay, we want to delay the timeout with that animation delay. And if we did not pass an animation delay, let's just say we initialize that as 150 milliseconds. Okay, after that timeout, or inside of the timeout, we're going to define an interval. So let's say const interval ID and assign it to a set interval function that also receives a callback function. And that interval, we're going to delay by 15 milliseconds. That I found very appropriate for the speed of code animation, so it doesn't take too long. The users don't get bored, but it's also not too fast, so they still see the entire animation clearly. Inside of this interval, we want to add to the text that is currently shown incrementally, right? So we're going to say set text to code.slice. So we're taking a part of the code that is passed into this component, and we're starting at 0 and going until I, so the index. So we're incrementing through every letter of the code and then animating that letter, adding it to the state. That's why we're also going to increment the iterator. We called I right here. And then also, if I is larger than code.length, obviously the animation is done, and we're going to say clear interval and pass in the interval ID. And also, this is going to be the animation we want to clean up after ourselves. If we are using with an interval inside of a use effect, we want to clean that up if the component unmounts, because else we might get a memory leak, because this would still be executed even if the component is not even there in the DOM anymore, right? So to clean this up, we're going to return a clear interval of the interval ID from the use effect. So whenever this component unmounts, this clear interval gets run, and we can prevent a memory leak that way. Great. Now to the dependency array, we need to add some stuff. So everything that comes from outside is generally going into the dependency array. If you don't know what the dependency array does, it reruns this use effect function every time a value in the dependency array changes. Inside of here, we want the code, the show, the animated, and the animation delay. So outside properties that we're using inside of the use effect, and that is it. Now we can get almost to writing the JSX before. We want to calculate the number of lines to dynamically determine the height this code should have. To do that, we're going to say const lines is equal to text.split. Remember, text is the state that we're keeping inside of this component. Now, to determine the number of lines, we're going to split this text at a regular expression. And to create a regular expression, we are going to create 2 slashes inside of here. It's going to think we want to comment, but if we type a backslash, it already recognizes that it's not a comment. And then for this regex, we want to split the lines at every occurrence that could be a new line, right? And to do this, we're going to pass the R as the first for the regex, then a backslash, and then an N, then a pipe operator, the one you also use for the OR in JavaScript, a backslash, and then R, or a backslash, and then N. That is the regular expression we're going to use. So at every RN or R or just N, the N standing for new line and the R being a comment symbol that is also associated with a new line. So either this or that or this N we're going to split at to determine the number of lines. And then const theme. So the theme we want to use for our highlight component, it depends on whether the state of the application is in dark or in light mode, right? And this theme is going to be equal to, and if the application theme is equal to light, then we're going to render out this as the light theme and else as the dark theme. Now, where do these come from? These are imports we can make from the library that we also get the syntax highlighting provided by the Prism React renderer, and we import them from separate modules. So we can say import, and then let's call this dark theme from, and in here we can say Prism React renderer / themes, and then the dark theme specifically is coming from Night Owl. And VS Code is really slow again. So let's just say Night Owl in here, and then also import the light theme from Prism React renderer themes, same thing again. And then there's a theme called Night Owl Light that we're going to use for this. I can close that down. It's a bit easier to see the code. And now we have the dark and the light theme imported from Prism React renderer that we can then use for the code down here. Now, let's render the highlight component that we also get from Prism React renderer. That is essentially going to do the syntax highlighting for the code for us. And let's spread him some default props that we also get from Prism React renderer. The code that we want to show in this component is going to be the text that we're keeping track of in state. The language is going to be the language we are passing in as props to this component. And then one last thing, the current active theme for this should be the theme that we have determined right up here. Okay, great. And inside of this highlight component, we can benefit from a lot of stuff that it provides to us. Namely, we can destructure some stuff like the class name, the tokens, the get line props function, and also the get token props function, and then return some JSX from that. In our case, that's going to be a pre, because we're rendering code and we want to follow accessibility best practices and do semantically correct HTML with this pre element right here that we use to render code. Now, if you want to get into this component, this code component in detail, I did a full video on this, explaining you how to build this. But nevertheless, I don't want to just copy paste this. I want to build this out together with you. So let's give this pre a class name, and that class name is going to be whatever class name we already got, plus a bunch of properties like the transition all to make this animated smoothly. We want a W of fit, a background of transparent, a duration of 100, no padding on the y-axis, and a no scroll bar directive added to it. Okay, and then we are gonna apply some dynamic styling to this using the style attribute we get from React. And the styles we want to apply are the max height. This is gonna be, if we want to show this component, then the lines times 24 pixels for each line. And if we don't want to show this component, then this is gonna be 0, and this is throwing an error. And the reason being that this is of type string array right now, but we only want the length of how many lines we have. And that fixes the issue. And then the opacity, if we want to show this component, then the opacity should obviously be 1. And if we don't want to show the component, then the component will not be shown with 0 opacity. Great. Inside of the pre, let's map through every token, tokens.map. And if you don't know exactly what these tokens are, don't worry about it. It's kind of some abstract stuff that I don't fully understand either. It's something you can easily get from their documentation. So the point of being a good coder is not to understand everything perfectly, but to know how to use documentation well, because if you try to understand everything, it's kind of impossible to do, right? You just have to know how to read documentation well and apply it to your own projects. So, but that's besides the point. Let's go through every line and then every index and render out some JSX. And for this line to work that we're going to write right now, the const key and the rest that we get from the get line props, we can call that with the line, and the key is going to be the index of what we're currently rendering. For this line to work, this is going to throw an ESLint error, specifically because we don't use the key value. However, we need to destructure the key value to not be used in the following components to prevent a React error. So we're going to say ESLint disable next line no unused vars, because we're not using that key as I just said. And then we can return from this tokens.map a component with a div with a key of, let's just say the key is a template string. Let's call it line dash and then the index. And that div is also going to get a style that we can put in like so, with the style we get from React with a position of relative. And there we go. That's almost all we need to pass to this div. One more thing, we're just going to spread in the rest of the properties that we get from get line props. And that's things like determining the styling of a current line or letter that we don't need to worry about because we're letting this package do it for us. And inside of this div, we're going to do one more map, and that is through every line. So line.map, and then for each line we get a token, essentially like a letter, and then an index that we want to get. And don't worry, we're almost done from this. It's like 2 or 3 lines of code. In this, we're gonna return a function, so not JSX just yet, because we're also gonna do the same thing with ESLint disable next line, and we can just copy and paste it from above the no unused vars, because we're gonna do the same thing and destructure some stuff from get token props that we also get right up here. We destructured it at the beginning, so we can say get token props. And in the get token props, if we take a look at what this takes, it's a token, class name, key, or style. And in our case, we're going to pass the token and then also I. And we can destructure from that the key that we're not going to use and also whatever is left using the .. rest operator. And then to get the squiggly red lines away, we need to return something. And in our case, that's going to be a span. The span is going to have a key of the index. And then inside of the span, we want to spread in all the props that we get. And yeah, not to get a naming error here, we can call this props instead of rest. I think that makes a bit more sense. And that is the token component done. Completely done with animated code. And while this was a bit of a hassle to write, I'm sure it's not the most intuitive thing to write this. That is totally understandable. I feel the same way. It makes for a super convenient code component that we can use in the parent component. So for the code that we want to render, it takes first we probably need to import this code component. And let's not do this from ./code, but rather from @/components/code. This takes a bunch of properties, as we know. It takes the code, language, show, animated, and some optional properties. The language we already know is JavaScript or TypeScript, doesn't really matter. Let's go with JavaScript. Then the code, we still need to pass. And what is the code gonna be? Well, let's create a new file for that only contains the code. Inside of our main directory, the source directory, let's create a folder called helpers. You could also call this constants if you wanted to put this under constants. Both approaches are perfectly valid. And let's call this documentation-code.ts. Not tsx, we're not going to render any JSX in here. Rather, let's export the const of Node.js. And this is going to be a template string. And I don't think it makes much sense typing this out ourselves. This doesn't really add to the video. So let's go into the GitHub repository, into source, and then helpers. If you called it the same, you want to paste it into helpers as well. Then into documentation-code.ts. And let's copy and paste the code from here. This is not actual code that goes into a project, but rather one string that we want to be displayed on the documentation page later. Let's paste it in here and be careful, indentation matters here. So if I move this to the next line, I'm going to show you what happens in a second when we render that out in our project right here. And let's also get the Python code that we need to display or want to display on our documentation page and export that from here as Python. You could also call this Python code. That would also be good. And paste it in here. Save that, and now we can import the Node.js code that we've just defined into our code component. And then also we need to pass one more thing, which is that we want to show this component, yes. And let's see what happens. So let's go back to our page. And if you take a look at this, well, the code is there, but it's not animated. So how do we animate it? Well, it's as simple as passing the animated property to our code component. Let's restart this. And as you can see, the code is being animated beautifully. And you might see, yes, it's clipping out a bit. And that's what these simple bars are for. But first, we want to also get the Python code working. So let's do the exact same thing. Actually, we can just copy and paste this JavaScript code. If you're wondering how I just did that, copy this line. It's Shift, Alt, and arrow down. And then if you let Shift go and just hold Alt and the arrow keys, then you can move that line around if you wanted to. So let's cut that, paste it in the Python, adjust the language to Python, and then also show the Python code in here that we get from the same file. And that is going to make both tabs work perfectly. Now, for some reason, the animated is gone. So we want to add that back for this to be animated. And then the simple bars come into play. So say you're on mobile, right? This looks pretty bad. And that's what these simple bars are for. So we can wrap this in a simple bar. Remember, we got that from the simple bar React. I noticed that my camera just died, but we're back. Camera is working again. Okay, where were we? We passed the Python code and now we're at the simple bars, right? So let's add in the simple bars. You might not notice any, change. And we are getting a client error. So let's declare this documentation tabs as a client component by saying use client. We don't want any Windows updates right now. And the reason we can do this easily is because, remember, we're rendering this client component inside of a of a server component. Now this scroll bar doesn't look insanely good. And the way we fix that is by also importing the CSS we need for this. We could either import this in the page or in the documentation tabs. Let's import this here. So we're going to say import and then the simple bar dash react slash this for distributable and then simple bar dot min for minified dot css and click save. And hopefully if I refresh the page, that simple bar is looking a lot better. Now the color is not perfect yet. We're going to fix that right now. But you can see for mobile, this is way prettier. So people on mobile devices can also swipe to the left to see all the code that is inside of here. Now let's do one quick thing, and that is adjusting the styles of the scroll bar. Right now we're in dark mode and it's black, so it's kind of hard to see it. So let's say that for the dot dark and then dot simple bar dash scroll bar and then double colon before, because that's how we target the style of this. We can say background dash color is gonna be white. Accept that. And now if we reload the page, the scroll bar should be white when we are in dark mode. And it's not, because we've scroll bar, because there's a little typo there. And now, as you can see, the scroll bar is white. It looks way clearer on dark mode to the users, that they can also choose this option to go to the right hand side of this code. Great. I think that is the documentation page done. We can switch between Node.js and Python. We can check this out on full screen, switch between light and dark mode, and the code will always look good. Really, really good work. And I'm happy we got to this point of the application. Great. Okay, so a quick summary so far. We've done the homepage. The homepage is fully responsive. If we take a look at this, the image goes with the page. It looks really nice. Everything is available in light and dark mode with a beautiful animation here in the toggle. And we've got a working documentation page also in light and dark mode. I think it makes sense to tackle the authentication next, because right now if we click the sign in, nothing happens, and that shouldn't be the case, right? And for authentication, we're going to use NextAuth. And the easiest way to get started with NextAuth is by visiting their documentation page. So let's go to NextAuth documentation and see how we can best get started with NextAuth. So we can go into the documentation section. Let's make this full screen for now and click on getting started. And the easiest way to get started is you can see the API route right here, creating the API route, and then NextAuth.js will worry about everything that is sent to that API route. So let's do that in our application. Let's go into the pages directory, source, and then we want to make a pages directory. It doesn't exist yet. We're going to create that, and in here we're going to have the API. And then if you take a look at the path right now, next should be auth. So let's create a folder called that auth, and then a file that is a catch-all syntax in these brackets saying ... nextauth.ts, and click enter. And the only thing we're going to do in this file is say export default next auth, and then we're going to pass some auth options in here, which don't exist yet. We're going to make them ourselves. And the reason we're doing this is because I feel like if you want to prepare libraries for your application, that shouldn't be done in a route, but rather in the lib folder. I think that is easier to wrap your head around if you want to maintain this project. And we can import the NextAuth from NextAuth/, and that should not be /next, just NextAuth. And then I think that could also work with the next, I'm not sure. And then the auth options we want to get from the lib. So let's create a folder in here called auth.ts. And this is where we are going to define all the authentication stuff we need to work with NextAuth. To get started in this file, let's export a const called auth options. And now to make sure the type is correct, we can import a type called NextAuth options that NextAuth provides to us. So this is to make sure that this NextAuth function gets the type it expects. And this is just going to return an object. It's going to be equal to an object. And then here we're going to define everything that we need to. Now this is going to complain because there are some properties missing that we still need to define in this file. So if we take a look at what exactly, it's the providers, an adapter, we can provide some optional stuff, and we're going to only utilize some of them. First one being the adapter. This is to make Prisma or database work well with NextAuth. So we're going to say Prisma adapter, and then here pass our database. Now the database doesn't exist yet. That's the interesting thing. And I think the easiest way, so this is the thing, right? Auth and database are very closely linked together. So I can't just walk you through the auth and then the database. We kind of need to do both at the same time because they are, as I said, very closely linked together. So the easiest way to get started with Prisma is to say yarn Prisma init or npx. I think it's npx Prisma init. That is going to put a Prisma file into our project with a schema.prisma, in which we can then link our database URL. However, for now, we're not going to worry about the Prisma file itself, but first we just want to export the database, even if it's just a mock or it doesn't really work yet. And to do that, we're going to create a db.ts inside of our lib folder. Now, the reason I'm calling this db instead of Prisma is because it should be kind of database agnostic. If you wanted to change this to MongoDB later, then you'd only need to change this file and not the whole naming convention of your application. Now the code for this Prisma database is just a copy and paste from the documentation. There's no point in writing this yourself. It's kind of confusing. So we can go into the GitHub repository once again, then into lib and then db, and we can just copy this code. I don't know, like I didn't memorize this code either. We can just copy paste this because of the documentation, and it's all written out for us by the Prisma team. Essentially what this does is we check if there's a Prisma client already, and if there's not, we're going to create a new one, and if there is a cached version, then we're returning that cached version, and that's it. Which means now that we've got that done, we can close a lot of these files again, like the documentation tabs and the page. We don't need those for now. We can import the db inside of our auth.ts folder from ./db, and I think there is an import that we want to use for this, so /lib/db. Then the Prisma adapter we also need to import, and that comes from a dependency we've installed at the beginning of the video, if you remember, probably not, called Prisma adapter, and we get that from at nextauth/Prisma adapter to make NextAuth work well with our database. Now the second thing we're going to pass into this is the session, and the strategy we want to use for the session. As you can see, we can pass the strategy property in here, a bunch of other stuff that we don't really want to worry about. We can select between JSON Web Tokens and database. In our case, we want JSON Web Tokens, and you might wonder, Josh, why are we doing this? The reason being that if we select JSON Web Tokens, one, that extracts a lot of logic away from our database, making it easier to scale because we're managing the sessions with a client. And then secondly, it allows us to validate the JSON Web Tokens integrity in middleware, whereas with where we keep the session in the database, we couldn't do that. And we are going to need that to protect routes very easily. And so I think JWT is definitely the way to go if you want to have an easy time, allowing certain routes and disallowing others depending on the user role. JWTs just make that way easier. And then for the pages, we want to define a custom page. By default, it's always the /API/whatever. If we click on sign in, you can see okay, so it's the API auth error, whatever. We don't want those pages. We want to override them with custom NextJS pages. The way we do that is by passing, in our case, the sign in, and we want to map that path to the /login page that we're going to create. It's going to be a super simple page that just allows users to log in with their Google account. And then for the providers, we need to pass a comma here. For the providers, there we go. The only one we're going to allow NextAuth to use is the Google provider. So we can say Google provider. And we also need to import that Google provider. we can do that by saying import Google provider from and then next-auth/providers then /Google. You can see there's a bunch. We could import like auth 0, Cognito from AWS, but we want to use the Google provider. There we go. And the Google provider takes two properties that we can pass it like that. And if VS Code loaded, I could show you this a bit easier, but VS Code is slow as hell sometimes. It's the client ID and the client secret. Now to get these, we're gonna create an environment variable, or we already have a .env that we can use because Prisma created this for us. However, for your environment file, I made it very easy for you to follow along. You can go into the GitHub repository, and then there is an .env.example I've created for you. You can just copy paste this mock.env that I've created for you into here, and all important files that we're going to use throughout the application are in here for you. So Redis for rate limiting, the OpenAI key, a database URL, the Google credentials we need, and then also the next auth values. Just paste that into your .env, and we are good to go for now. So for the Google provider, for the client ID, okay, now it works. We want to pass the process.env.google_client_ID that we get from the .env file, the Google client ID right here. And then the Google client secret, I need to insert a comma here. The client secret is going to be the process.env.google client secret. And now it says type string or undefined is not assignable to type string, so it's quite mad at us. So to make this a bit easier, we're gonna create a function called get Google credentials. And it's not gonna be an async function, it's gonna be super simple. We're gonna say const, essentially we can just copy paste this and put it here, then put a const before each of them. And if you're wondering how I typed in 2 lines at the same time, when you click somewhere and then hold Alt and click somewhere else, you can type at 2 spots in your VS Code. It's super handy. Let's do that again. Oops, they need to be at the same place, and then it's going to be equal to process.env.whatever. These commas can be gone. There we go. And why is this still? Okay, the function is initialized differently. I try to mix up a constant function with a regular function. And if there is no client ID or there is no client secret, then we're gonna, or actually no, that's not what we're gonna do. If there's no client ID, or if the client ID dot length of the string is 0, it's gonna equal triple equal 0, then we're gonna throw a new error, and in here you can write what you want. So for example, no client ID for Google provider set, so that you know in development that you forgot to pass that. And same thing goes for client secret if there is no client secret, or the client secret dot length is triple equal to 0. Then we're gonna throw a new error. Essentially we can just copy paste this. This is just an error for you anyways. We can just say no client secret for Google provider set. And otherwise, if both are fine, then we're going to return an object containing the client ID and also the client secret. There we go. And now instead of choosing these environment variables, we can call the get Google credentials and then dot client ID. And same thing goes for the client secret, get Google credentials, invoke that function, and then client secret. So that means we always know when this gets rendered, we have these values. Otherwise, an error would be thrown first, so we can be sure these are just strings we're passing to the Google provider. Great. And then I think, is it one final thing? It's almost one final thing. One thing is we want to pass the callbacks. So we're going to extend our session, async session, like that. It's a function that we can invoke, and essentially when a session is created, this function will be called from NextAuth, and we can define some custom handling in here. We get values that we can destructure and use, like the token and the session that we want in our case. And we're gonna do some extension of our session. So if we have a token, if we see or take a look at the token value, you can see it's a JWT. That's what this token means. If there is a JWT when this function is called, then we're going to extend the session by the values of the JWT. So we can say session.user.id is going to be equal to token.id. The session dot, actually we can just copy the session.user a bunch of times. Session.user, session.user, session.user. The dot name is going to be equal to the token.name. The session.user.email is going to be equal to the token.email. And the session.user.image is going to be equal to the token.image. Now you might notice this throws a bunch of errors, and that is because we haven't defined a type for our next auth. So because we're working in TypeScript, we need to tell TypeScript what are the types for next auth that we would like to be using. And we're going to do that in a separate folder. Let's call that types. And here, let's create a TypeScript definition file by saying next-auth.d for definitions.ts. So this means there is no logic in this file. It's literally only types. And what we want to pass in here is the following. First off, we want to disable the ESLint unused vars, because this will keep throwing an error if we don't. So ESLint dash disable dash, or actually no dash, ESLint disable, and then no unused dash vars. So this means we're disabling ESLint for the whole file and not just for one line. And then we're going to import two things, the type session and also the type user. Because these both are types, we are fine just saying the type before the actual import from next-auth. And then lastly, we want to import the type of JWT from next-auth/JWT. Great, and now let's define the types. So the type of user ID that we want is going to be a string. And then let's declare the module of next-auth/JWT first. So we're going to say declare module, and then call it the next-auth/JWT, essentially defining the global scope or global types for this particular module that we're declaring right here, that TypeScript always knows and always falls back to. So in here, we're going to say interface JWT, extending that by an ID, user ID. So the JWT that you just saw right here, we're changing that right now. And then also we want to declare a module next-auth in general. And that is going to contain an interface called session. And that session has a user property that we want, which is of type user, and also a ID, which is of type user ID. And I spelled that wrong, declare. There we go. So now on the session, we also have a user, which we have extended by the regular user that we imported up here, and then also added an ID property of type string to it. Great. So you can see a lot of the errors went away. There's still one error, not 100% sure, but we're not going to worry about it for now. And then return the session from the async session function. Okay, I think the reason is because this is called picture. Yeah, it's called picture. It's not called image, but on the session object, we are calling it image. You could call it picture. That's fine too. I prefer to call it image and not picture. Great. Now for the JWT, async JWT. By the way, if you're wondering how I came up with this, I didn't. This is just according to the NextAuth documentation. If you want to read up on anything that we're doing right here, it's all explained in the NextAuth documentation super well. If you get confused on why we're doing any of this. For the JWT callback, we can destruct the token and the user that we then want to modify. So in this callback, we can say const dbuser to check if this user already exists in the database. And this is the first time in the whole application that we're making use of Prisma as our database. So we can say await. That's why this is async. This wouldn't even need to be marked async. Await, and then db that we can import dot Yeah, okay. And now we got the case that we don't have any Prisma types for now. So probably it makes sense before we continue on the authentication to actually get the Prisma types done right. Let's go into schema.prisma and actually create some models for our database. Now we don't need to think of all of these types ourselves. Instead, we can go to NextAuth and then search for NextAuth Prisma, and they already provide a super good schema that we can use for Prisma containing the user model, the session model, verification token. Super handy, and we're gonna base our Prisma schema on that. So let's find that file on nextauth.js documentation and paste it in here. And that's already most of the work for our database regarding the authentication done. Now we are gonna extend this a bit while we're already here, but most of this is gonna stay just the same. But since we're already here, we can right away extend this by the API key logic that we want to have later. So the API keys, right? How do they work? Well, we're going to create one model called API key and one model called API request. And for every request, it is also mapped to which API key has made that request. And the API keys are not deleted when we revoke them, but rather they are disabled, but not deleted. That's a major difference. So let's start with the API key model first. This model is going to get an ID, which is going to be of type string at ID. That's how we define an ID in Prisma. And then by default, that's going to be a CUID, a collision resistant ID. We want a key, and it's going to be a string at unique. So this is going to be the API key itself that the user will see in the browser. That should be a unique key always. They cannot be duplicates. Then we want an enabled property that we can then later modify to disable or revoke a key. That is going to be of type Boolean, and by default, this value is going to be true. So an API key, once generated, should be always default, unless we say otherwise. Then we want to make a reference to a user, which is of type user, at relation, and the relation is going to get this field called user ID. And then also we want to say that references the ID of user. And then it might complain, yeah, because we also need to define the user ID of type string. So we are determining which user does this particular API key belong to. Then the requests this API key has made, requests, there we go, is of type API request array. That's the model we're going to create right now. And then each API key should be unique in the sense that it has a unique like the constellation of what we're passing right now, the key and the enabled. All three, when taken together, always are unique. There could be a user ID and a key, and those similar across multiple instances of this model, but there is never a user ID and key and enable that has the same value of all three of those. So that's what this unique means. And then let's create a model for the API request. So each request to our API will generate one of these models or one of these instances of the model API request. This is gonna get some properties, namely the ID of, oh no, that's not gonna be a colon, of type string. This is gonna be an ID, and by default, also a collision resistant ID. Yeah, I know, okay. Then the timestamp, when was this request made? We also want to save that. That is of type date time. And by default, that is going to be now. Then a method. So for example, post or put or patch or whatever. In our case, we only have one API route of type post. But if you wanted to extend this, super handy. The path of the endpoint, so /API v1 similarity, for example. The status is going to be int, so the HTTP status code, for example 200, that gets returned. The duration of this is going to be an integer. Then a used API key for this request is of type string, needs to be uppercase. So for each API request, we're also storing which API key has made this particular request. And then this might seem like a duplicate information to what we're doing right now, because we also want to save the reference of the API key. But I'm going to explain more why we do that here after we type this out. That gets a field of API key ID, and then it references the ID. And for that to work, we also need to pass the API key ID of type string. That is the value right here. Okay, and because we can expect that there will be a lot of API requests, we also want to create an index. So this query will be faster to the API requests. And this index we're going to create on the API key ID and on the timestamp. There we go. Great. For a database model, there's one more thing we want to keep track of. And actually, I think that is already working. So one user has an API key. That is correct. However, one user also has an API key ID, which is of type a optional string. And that is it. Great. We can save that database schema. And for this to work, we insert one more thing at the very top of this file, and that is the relation mode we want to use. In modern Prisma, we can pass that, and that is of type Prisma, because otherwise we wouldn't be able to use these foreign keys. Now, it does suggest this is outdated, but I found this to be the working solution. So I'm using this all the time. I think it's a good solution for this. And now that we've created this file, we want to push it into our database. However, there is no database yet, right? And for the database, we're going to be using something called Planetscale. It's a cloud-hosted MySQL service. We're going to sign in. If you haven't, you can create an account in the service, and they are using Vitess under the hood. It's a technology to handle database scalability. It works super well. It's a fast database, and I've had a really good experience using Planetscale. Now, getting started with Planetscale is super simple. You can log in using something like GitHub, and then let's create a database together. In my case, that's going to be in EU Central, but obviously you would want to create it closest to you, and let's call this similarity-YouTube, and then click Create Database. Now, before that's even done creating, we can already get the connection string that we need to connect to our database. There are so many options in here, like .NET, ASP.NET, or Java, whatever you wanted to use to connect to your database. In our case, obviously, we're going to select Prisma for Node.js and copy the string right here. Now, I'm going to obviously revoke this string after we've built this, but this is where you find your connection string while it's still initializing. And then let's go back into our similarity YouTube project. And as you can see, for the Prisma database, we have linked the environment variable called database_URL. And since we've defined the environment variables, we can just paste it right here. And then we can start pushing into our database. Let's say yarn prisma db push or npx prisma db push, meaning we push those changes we made in our database file up into the actual database. And that did not seem to work because we also need to define MySQL instead of Postgres up here. Let's try that again, clear the screen, and then push that into our database, and hopefully that will work just fine. And now for our local development, we want to run yarn prisma generate. Prisma, if you don't, is fully type safe, so it generates the types for us. And for that to work, we also need to generate the types after we pushed into our database. And also we probably want to restart the Typescript server to reflect those changes. Great, we're making really good progress. And now we can also use the features right here. We've got on the auth.ts in our lib. Now we can actually find users. So we can say, oops, db.user.find first, invoke that. And in Prisma, we can find by a couple of options. We can say where, and then, there's a lot of options we could use, but we want to find the first user of our application where the email of that user is the token.email. So whatever the JWT tokens that we receive here contains as an email. And then by that, we are finding out whether this user already exists or not. And if there is no DB user, if this user doesn't exist yet, then we're going to say the token.id, so we're extending the JWT, is equal to the user, and I'm using a, I think it's called exclamation mark to let TypeScript know that we know this exists, .id. And then we're going to return the token from this async JWT function. And if there is a DB user, if that user already exists, we're going to return an ID of dbuser.id, a name of dbuser.name. So we're just forwarding the values of the user that already exists in our database, the email of dbuser.picture, or no, it's, yeah, we call it image, right? And then the picture, wait, no, the email should be the image. No. The email should be dbuser.email, and then the picture should be dbuser.image. There we go. We don't want to pass an image string as the email. That would be pretty bad for authentication. And then one last thing, 3 lines of code we're going to add to this file is the redirect. So after a user has logged in, we can redirect them to whatever we return right here. In our case, that's going to be the /dashboard that we want to redirect users to. Great. And that is the auth file fully done. We can now import these auth options into our next auth route. Now everything is coming together. This is working nicely. And we could almost try this out. One thing you'll notice is when we start up the localhost server, let's move this over a bit. I think first off, we need to start the server again. And then secondly, we might only get so far as to getting a rejection by Google because they don't know the credentials, right? So we don't have a Google client ID and client secret set yet. And first off, we're getting an invalid URL from the navbar. So let's take a look at that and work on fixing that. Right, because we don't know where we need to get the server session from, we also want to pass the auth options that we have just created into this get server session. So next auth knows, okay, this is where we're getting it from. And now we're getting the error no client ID for Google provider set, exactly what we want, because actually we haven't set those credentials yet. Now the Google client ID and client secret, getting those is really not very difficult. We can go into the Google Cloud Console, and there are a billion good tutorials on this on YouTube. Let me log in here, and here we are inside of the Google Cloud Console. Now I've already got a project here, but if you don't, and chances are you don't, you want to create a new project, you can call it whatever you want. I call it Similarity API. And then under APIs and services, we can go to login data. Now, if you haven't created the project, go ahead and do that. It's super simple. And then you want to click up here on create sign-in data, I think it's going to be called, to create an OAuth 2.0 client ID. And within this OAuth, we want to configure multiple things. So for local development, we want to create an authorized JavaScript source. That is going to be, for once, the local host that you're developing on. And then secondly, any deployment URLs that you want to use later on. And the same goes for the authorized redirection URIs, essentially whatever URL you want. And then the /API/auth/callback/Google, because that is what Google is going to call for your application. And that is all we need to do. Create a project, get your OAuth sign-in data. If you don't know how to do that, just create a new project, like here, up here, new project, then give it a name, YouTube test. We don't need to save it in any organization. That's going to be creating the project. And then once it has been created, we can switch over to that by going up here and then into YouTube test. Now we are inside of this project, and now we can go to APIs and services and then login data or sign in data, and then create new sign in data, OAuth client ID. That's what we want. We can close the notification. First, we need to configure the agreement, like what the user sees when they try to log in with Google. So on this right here, we want to select externally so all people can see it. We want to give it a name, a support email. We don't want to create a logo because then I think we'd have to verify your application. As you can see here on the right hand side, this is what the screen looks like in the end, right? And then give it a domain, the authorized domain, and then contact data for you. And that's all we need to do to create this. And then you can do what I just said with the OAuth client and get your Google client secret. It's honestly super straightforward, not hard to do, if you follow just the steps that I just outlined for you. And after we did that, we can get the Google client ID and also the Google client secret, paste them in here, and I'm just going to use the ones I use for the actual application. And we can also open Chrome here on the right hand side again. So let me go into my actual application and just paste over the values. Now obviously I'm going to change them after the video, so it would be best if you get your own values. Let me just paste them in here just so we get this working for the video. And now, because we changed the environment variables, we need to restart the server for the server to reflect those changes. Let's restart this, and then we should actually be able to log into our application. Okay, it says invalid URL again. And the reason for this error is because we haven't set in the env the NextAuth secret and the NextAuth URL yet. Now the NextAuth secret is what we use to sign our JWT tokens. So you can enter anything in here, anything, my secret to sign JWT. It should obviously be something way more secure than this. So a random string that you generate, probably not on the internet, but on your local machine. That would be best practice. Then for the NextAuth URL, we're going to use our local development URL because this .env is only in local development anyways. It's going to be localhost at the port of 3000. Save that. Then once again start or restart the server. And now that error should be gone because we have defined our NextAuth URL. And NextAuth should now know how to get the server session. And it does, great. Now let's take a look at what our work has done. Let's click on the sign in button and we get forwarded to the Google sign in. Great. And if you click this button, we get forwarded or redirected to the /dashboard because that is what we have configured in the auth settings right here at the bottom, returned /dashboard. However, that route doesn't exist yet. So it would probably make sense to next up configure that route, and let's go into a proper split screen here like that. So it would probably make sense to configure that dashboard route next. Doesn't exist yet, right? So we can go into our source and then into the app directory, and let's create a new folder also for management. Let's put this in the I think it's called parentheses. Let's call this dashboard. It's just for organization. This is not a URL change. Let's create a folder in there called dashboard. And inside of that dashboard folder, create a page.tsx, which will mean that this page actually now exists and there is a page that is being rendered on the dashboard. Great, that's a good first step. And slowly but surely, we're getting closer and closer to the finish line. We have done a lot of the important work already, the groundwork for the project. So building this page and the following pages is actually going to be much easier than if we hadn't. So if you're at this point of the video, congratulations, and let's plow right ahead. So for the page.tsx, we are not going to receive any props. We can remove all of that from the initial component. And let's define the metadata first. So import type metadata from next. And then right below that, let's define the metadata, export const metadata of type metadata that we've just imported from next. It's going to be equal to an object. And then you already know the drill, how this works. The title of the page, this is going to be similarity API, and then the pipe dashboard. However, feel free to name this whatever you want. Dashboard and then a comma there. Then on the next line, we want the description, which is going to be free and open source text similarity API. Period. Oh, no period. Doesn't matter. Great. If we save that, take a look at the page. Right now it says, okay, it already reflected the changes. Never mind. But anyways, that's great. And then this page, the logic for this page is going to be pretty simple. We first want to define the user. So to get the session, you already know how this works. It's the await get server session that we get from NextAuth. Super simple. And then here we want to pass the auth options. Now for this to work as a wait, we need to mark this page as asynchronous, and let's just remove the FC because it will conflict with that. And then if there is no user, let's just for now render a p tag called no user. We can still change that later, and we want to return that. And then, or you could also have a not found error from next navigation right here, and that would navigate the user to the this doesn't exist page. I think this would be a better error handling actually. Let's leave it like that. And the const API key is going to be equal to await, then database dot API key, the model that we've created, dot find first. Now, what is the key we want to find for user to determine if an API key is valid or not? Well, first off, we want to find the key where the user ID matches the user.user.id. So the user, remember the current session that is logged in, and also the enabled property of true. So we only want to get the key where that is actually enabled to check whether this user has a valid API token or not. Then what we're going to render is going to have a class name of max width of 7xl, a margin x of auto, and a margin top of 16. Kind of give this an offset of the navbar. And then on the page, we're going to do some logic. So if there is an API key, that means there is a valid API key, because the type of this is either API key that we get from Prisma client or null. And if there is an API key, then we're going to render something called API dashboard. And if there is not an API key, then we're going to render a component called request API key, and that's it. Great. Now these components don't exist yet. And I think it makes sense to get started with the request API key first, because that is the easier component. Let's create that under components and then request API key.tsx. Initialize this as a TypeScript component, and we can also already do the same for the API dashboard, just so we don't get the errors. Let's create the API dashboard.tsx. Also initialize this as a TypeScript component and then import the API dashboard, and there are no more errors. Great. Now there's no particular logic involved, but at least the errors are gone. Let's close all the pages and then go into the request API key page, and let's get started working on this page. And because we laid all the important groundwork, this part of the website is going to be really enjoyable to build. Now this is not going to get any props either. We can remove that. And now let's get started. This is going to be a client component because we do want some interactivity in here. So let's say use client up here and then define some state. So first one is creating. So if the user does not have an API key, and set is creating, by the way, if the user does not have an API key, then we want to create them one and also get the loading state whether that is currently creating the API key or not. That is going to be equal to a use state that we get from React. And that is going to be false by default. And just to make this a bit clearer, we're going to also pass the explicit Boolean value for the is creating. And then the API key that has been generated, let's call it API key and set API key, is also going to be a state. And that state is going to be either a string of the API key or null. And by default, obviously, it's not going to be string, but rather null. Great. And now let us create the function to create a new API key. So const create new API key, and it's going to be equal to an async function. A constant function, you could declare this as a normal function if you wanted to. And then first thing we want to do is prevent the default behavior, because we're going to do this through a form element. So we're going to get a form event like that as an event. And this is going to be of an HTML form element generic that we can pass into the form element. Essentially just meaning that we can prevent the default behavior, which is to put the data in the URL. We don't want that. And it would also refresh the page. We don't want that. Now to create a new API key, first off, let's set is creating to true, because no matter whether it's successful or errors, it's always going to be creating at least for a while. And then let's have a try catch block below that. Let's call this error. or error, it doesn't matter. And then let's say const generated API key is going to be equal to await create API key, which is a function that we have not created yet. And then set the API key to that generated API key that we have just generated. Now this function doesn't exist yet, but let's worry about the error handling first. So if the error is an instance of error, which is a global class that we always have access to, if error instance of error, there we go, then in that case we know that this error has a message that we can use for the toast notification. So we can say title and then, for example, error, and then as a message for this toast we can pass the error dot message. We know that exists because we did the instance of type check up here. Then lastly, we want to pass a type of error for this toast notification and return, because otherwise, if this is not of type error, we don't really know what the type is, then we're just going to pass a generic error message with a title of error, a message of something went wrong, because we don't really know what went wrong, then a type of error as well. Great. And then finally, after all that is done, we've got the catch right here. And then finally, no matter what happens, whether we catch or the try is successful, we want to set is creating to false, because at the end, we're done creating this. Now this create API key doesn't exist yet, and I think it makes sense to create this function right now. Okay, so my camera went out again. I hope it wasn't out for too long. I don't really know. And to create this API key function, we're going to create a new file in the helpers, and then let's call this create-api-key.ts. Great. And then here, let's export an async function create API key. And what this function is going to do, I think the naming can already kind of tell you what it's about to do. We're going to create a new API key for a user. And to do that, we're going to fetch from an endpoint called create. So const response or res is going to be equal to await fetch. And then as an endpoint, we're going to pass /API /API-key /create. That's the endpoint we're going to use to create new API keys. And then the const data we get from that is the awaited res.json. And we want to infer that type, or cast that type rather, as create API data. So whatever we return from that endpoint. Now that type doesn't exist yet. Let's go into the types folder, and then we can create a new folder called like API, and we can have an index.d.ts in there, or .ts doesn't really matter. And let's define the create API data type, describing what the API route will return to us as a type. And we're going to do that by saying export interface create API data, which is going to be an object. And by the way, the reason we're casting this as this type is so it's easier to work with later. So we know what the response will look like with TypeScript. That's the main benefit of TypeScript if you've never worked with it. And to determine the shape of the response that we get back, we define it as a type right here. That's why we're doing this. That's also very important to explain. This create API data will have two properties. One's the error, which is going to be either a string or a Zod issue array. We're going to get into Zod in more detail in a second. But first, let's import that type Zod issue from Zod, which is a library to do schema validation we've installed at the beginning. You're going to see exactly what that is here when we create the API route. So don't worry if you've never worked with Zod, no problem at all. And then null could also be true for the error. And then the created API key is either of type API key that we get from the Prisma client. So exactly what we have in our Prisma schema, right? The API key that we've defined as a model, that could be the type of this, or it could be null if we weren't successful in creating the API key. And while we're already here, we can also export an interface for one more API route, and then that's it, I promise. The revoke API data endpoint, and that also has an error, which is either a string or a Zod issue array, or that could also be null, and then a success. that is simply a Boolean, either true or false, and that's it for this file. So we just described what the responses we get from the API endpoints that we're going to use to create and revoke API keys are going to look like if they are successful. That means we can import this type right here and plow right ahead with this function. So if we have some error, right, we can say data.error, or the data.created API key is not true, not truthy. So if the API key generation failed, then we're either gonna throw one error or the other, and that depends on the shape of the error. And to check the shape of the error, we can say if the data.error that we passed along is an instance of array, so if the error is in array, then we're gonna throw a new error of data.error.join. That's an array method we can use, essentially turning the array errors into one single string that we throw as the error. And otherwise, if it's not an array, then we're gonna throw a new error with the data.error. Now this could also be null, by the way, if this were successful, but TypeScript doesn't know that. So if this is null or undefined, then we're just gonna say something went wrong and not worry about it further. And that's the error handling done. We need to obviously catch this somewhere in a try catch block, but we are doing this right here. This would be the catch block catching the errors. And then if everything was successful, we can return the data.created API key, so the value of the API key, back to this generated API key right here that is calling this function. Great, and now we've defined the entire function in our request API key, and we can use that inside of the JSX to actually allow the users to request the API key themselves. Now, doing this is quite straightforward. We want to render out a div with a class name of container, and then also on medium screens, we want the max width to be 2XL, so it can't exceed that on medium or up devices. Then one more div in here, which is going to be of type flex, then a flex column, so we list the items below one another, a gap of 6, so we separate each item vertically by 6 units, so that would be 24 pixels, so 6 units of 4 pixels, and then the items dash center. Okay, and inside of this div is now going to be a key icon that we get from Lucid React, with a class name of mx-auto to be displayed in the center of the screen, with a height of 12 and a width of 12, and a text of gray 400, so it's going to be this color. Below that, we want to put a large heading, and the auto imports still don't work. Maybe I misspelled something, that could be the case, I'm not too sure. But we're gonna import the large heading from the add/component, or we can just go into UI directly and then large heading. Import the component we wrote ourselves, and this is gonna say request your API key. Now below that, we want to render out a paragraph also, and no, this shouldn't come from large heading as well. Yeah, so when we go into the large heading, why are there, okay, large. So this is the only file, right? And this is called, okay, so why is the large heading called paragraph? I think I messed something up. This should be large heading. I think we just copy and paste it over the code, right? This should be large heading as well. This is already large heading variants. Okay, so this looks better. And now the paragraph, did I mess that up too? When we import that, no, that is from UI paragraph. That works just fine now. This paragraph is gonna say you haven't, and then in here we're gonna write an and, or a, no, that is, yeah, an and then a pause, then a semicolon to simulate the apostrophe. I'm not sure how that's called in English, but this letter right here, you can zoom in if you want, the upper, I don't know what it's called, because in HTML we need to escape that to be rendered properly, otherwise it's going to throw an error during the build. And when we've done that, we can have a T, requested an API key yet. So you haven't requested an API key yet. Let's close that down, inform the user that they haven't done that, and then below that we're going to render out a form. Now that form is going to take an on submit. So what do we want to happen when this form gets submitted? We want to create a new API key. So we can copy that over, paste that into the on submit of the form. Then this form is going to get a class name of margin top of 6, a small flex, and small item center. So only on mobile is this not going to apply. And an action if we wanted to pass it as hashtag, but we are preventing the action anyways because of the e.prevent default, right? Inside this form, we're going to have one div like that. And this div is going to get a class name of relative rounded dash medium shadow dash small. And at small screens, this is going to be a minimum width of 0. And on small screens, this is going to be a flex 1. So take up as much space as you possibly can. That's what that means. And then we're going to do some conditional logic in here. If we have an API key, if it was generated successfully, we want to show a button that allows us to copy that API key into our clipboard, right? And if not, then null. So we're not going to render out anything in that case. Let's call this a copy button. Close that off, and that copy button doesn't exist yet, but let's pass it a class name already because we know that it will receive that. Class name is going to be absolute inset-y-0. If you don't know Tailwind very well, this is the top and bottom property essentially as one. It's super handy. And then right is also going to be 0. So we're positioning this at the right side of the input absolutely. It's going to animate in and also fade in. That's why we have the TailwindCSS-animate. So we can use these. It's going to look really good. And then a duration of 300 for the animation. Great. And then let's create the copy button really quick. It's a very simple component. Let's create it here under copy button.tsx. Initialize this as a TypeScript component. You know the drill. Now this copy button, because we need some interactivity in it, we're gonna have this as a use client. And then inside of this copy button, we're gonna extend the props. I think you already know this from the beginning where we created the reusable components to allow any prop that a button could normally have to be passed into this. So this extends the button HTML attributes, essentially meaning take everything from the normal button and also put it into here. So we can then, as you remember, this means what the props can be, right? So we're saying the props can be anything that we define customly inside of these object brackets right here, or everything that a button normally has. And then here we want to pass the generic of HTML button element. Close that down for better readability. Great. So now we can destructure some props in here, which would be the class name, and then everything else as ... props. Again, the catch all. Now there's one property we want to have in here, and that is we need the value to copy, right? So let's call this value to copy. Which value should be copied to the clipboard? That shouldn't even be optional. We always want this value. And we can also destructure that value to copy for this component. And now we're going to render out the UI button that we have created ourselves. This is super convenient, this button component. We're going to pass in all the props that we define wherever we render this component. Then this is going to be of type button, because we don't want the submit, this button to act as a submit button in our form, right? By default it is, but we don't want that to happen. So let's just define the type right here. You could also have this as props, obviously. So you could say the type button in the, well, we still needed to import this, right? So let's say, let's import this button and then say type is going to be button right here. I think that's a bit cleaner to implement. There we go. And then the onClick handler, right? So how do we copy something into our clipboard in JavaScript? The way we do that is through a function. And then here we can say navigator.clipboard.write text, and then the value that we want to copy into our clipboard, obviously with the correct spelling. And after we've copied that, we can send out a toast notification saying title of copied, a message of API key copied to clipboard, or make this something we pass from the parent component, which would probably also be a good idea. So the title and the message, I'm just going to declare it here, but I might change that in the GitHub repo. And then of type success, because we successfully copied to the clipboard. Then one property we want to pass to the button is a variant of ghost. So this doesn't appear too visually, like it's not very obvious that this is a button. And then a class name that we're conditionally rendering with the cn utility function that we have created in the utilities with an empty string, and then the class name as the second argument. So honestly, we could just actually leave this out and say the class name like that. Great. And inside of here, we're going to have an icon, the copy icon we get from Lucid React. We're just going to have a class name of height of 5 and width of 5, and that's it. Now, there seems to be one error right here, and that is probably we didn't handle the HTML correctly. So let's say, what's happened here? So /button, there we go, close that off correctly. Great, and now this button looks good. We don't need that anymore. By the way, if you're wondering how I remove the unused dependencies, it's Shift, Alt, and O. That's how you remove them in VS Code. And now this gives us an error because we also need the value to copy, which is gonna be the API key that we have generated, right? So we can just copy the API key and have that as the value to copy in our copy button. Really, really good. I think the last custom component for this entire project that we need to declare is the input. So we want to render an input here. However, that input doesn't exist yet. And I think once more, one last time, it makes sense to go into the GitHub repo, into the similarity API, and then source, into the components, UI, and then check out the input. Let me see, I think, yeah, the table we're gonna write ourselves. The table we're gonna write ourselves. So this is the last component that we're gonna use from the GitHub repo. It is pretty straightforward, but it is essentially just copy and pasting from Radix UI and then applying a bit of styling. So not a huge value to type this out ourselves. Let's move this to the right side and then include that into our UI components. So let's call this input.tsx and paste the code from the GitHub repository for the input. And what the pasting allows us to do is just move a bit quicker through this whole project. And the input we can now import from UI input. Let's have these as add, and then also the copy button would be add/components/copy button. This should be add UI, and this also add UI. Okay, I'm back. I took a little break, so the lighting might look a bit different, but let's continue where we left off, and that is with this input component right here. And we're almost done with the request API key component, by the way. So to this input, we're going to add a read only, because this is only going to display the API key, and the user should not be able to enter any information themselves into this input. Then we want this to have a value of the API key, or if that is null or undefined, that's what these two question marks here mean, then we're going to render out an empty string. And by the way, we don't want to render that input conditionally, but we want to move it below that conditional statement. And then lastly, for the input, we can put a placeholder that says something along the lines of request an API key to display it here. There we go. And I think that is the entire component done. Great. Let me check one last time. We've got the use client. Oh, we still haven't worked with the is creating, and the is creating goes into, okay, yeah, we forgot one very little thing, one minor detail, and that is the button component that actually submits this form. Let's wrap that button component in a div. We're almost done though. That's gonna get a little margin on the top side. On the small devices, it gets no margin though, just on the mobile. Then on small devices, we're adding margin left of 4. And on small devices and up, obviously, we're adding a flex shrink of 0. So it should not shrink. and then let's pass a button component in here. Inside of the button component, this is going to say request key, so users can request the key, and it's going to get a disabled of like that, and then double I think it's called exclamation mark API key. Now what this does is it turns the string or null into a boolean, and I think we could not leave that away. So this could be a string or null, and essentially the exclamation point turns something into a boolean but inverts it, so we want to invert it twice to convert it back to the truthy value, right? And then this is gonna get an is loading as well, and that is loading is gonna say is creating. So while it is creating, we want the loading state of the button to show. This button is not gonna get an on click, because remember, this is inside of a form, and when we click this button, it's gonna be a form submission by default. So this function is going to get called with the request API key. And we can check if this works. Let's go into the browser here on the right hand side. We can close a lot of this stuff down, and let's take a look. Yep, this looks really good. However, this is kind of clipped. So the way we fix that is, let's move that over just a bit. Let's create a layout for this route. So right now we're in the component, no, not in the components, in the app, and then in the dashboard. And let's create a route for this dashboard. So we need to expand this a bit, create a new file in the dashboard folder, layout.tsx. And inside of the layout, we are just, okay, yeah, we're getting an error, that's fine. We are going to export default layout from this component, layout, there we go. This layout is gonna receive children, and we can type the children out right now. The children are gonna be of type react.react node, so regular React components. And then from this function, we are gonna export, and this does not seem to work. Let's import that type from React, import type React node from React, like that. And I think I messed up the syntax somewhere. No, that looks good. Let's return just an empty div for now. No, that I definitely screwed up the, oh, I forgot the function keyword, export default function layout. There we go. And now we can return a section from this layout with a class name of padding top 20 to offset the navbar height. So this looks just right. And in here, we're going to render out the children. And that should prevent the clipping that you just saw happen here on the right hand side. And it does, really good. And we have the request API key. The button looks a bit weird. It looks too far to the left. So let's just add a flex to this div and then a justify center like that. And let's see if that works. Yeah, that moved the button to the center. And let's see how that looks on desktop and on mobile. That looks good. Great. All right. And now we are done with the request API key component. We can close out of the DevTools, and we can close this file and 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 this as well and that as well. Okay, so let's go into the dashboard. Let's see where we are at the page.tsx. So we've got the request API key component for when somebody has no API key. We don't have the functionality yet to check if this works. Now the question is, do we either A, define the API dashboard for when somebody has an API key, or first define the actual API key logic so that we could request one right now and then see the other dashboard? And I think that makes more sense. I think we're going to implement the API functionality, including the API routes to revoke and create an API key. Let's do that. That makes more sense. To do that, we're going to go into our pages, and let me see how I set up the routes here. Let's create a new folder called API-key instead of the API folder, right? That lives in the API, not in the auth. We don't want it in the auth. And then inside of this API key folder, we're going to have two files. One is going to be create.ts, and the other one going to be revoke, but we're going to worry about that in a second. We can maximize this because this is going to be back-end work we're doing and not front-end work. And then let's handle creating an API key for the user. So in all Next.js API routes, we're going to have a handler, which is going to be an async function. And this handler is going to be a default export default handler, like that. And inside of this handler, in here, we're getting two parameters for this function, which is the rec, a next API request, and also the res, a next API response that we can access within the handler. And there needs to be a comma there. And we need to import this type. And once again, VS Code is super slow in loading this. So I could manually import this, but that won't do much currently. So let's say next API response, like that, but it still needs to load a bit. So let's get started writing out the component and then worry about that later. So we're going to initialize a try catch block in this API route. It's kind of a pain that I need to do this manually, but whatever. Try catch error. There we go. Set up a normal try catch block. We can get rid of that. And then for the try, we want to get the user session first. Oh, it's finally done loading. Great. So we want to get the user session first, right? And the way we do that on the server, you might already know this, is by awaiting the get server session. And no, don't tell me it's loading again. Jesus Christ, man. I swear VS Code is like a slug sometimes. Anyways, this get server session is getting the request, also the response, and then also the auth options we can pass in there. And I would really appreciate if it let me load that. So let's give it a second. I'm going to be right back when it's finished loading. Thank the Lord, it is done. And let's import the get server session and the auth options. And let's attach a very quick and dirty dot. Then we get the response, and then we would want to return the res.user from that response. So we get the user or undefined as or user. And if there is no user, then we are going to return a res.status of 401.json and with an error message saying unauthorized to perform this action. And then as the created API key, we're going to put no. By the way, to enforce these standards in the response, we can actually pass the types we have created. Remember, we have created at types API index.ts the create API data. That's what this is for. So we can pass that as a generic to the next API response. Just pass it in there and also import that from the at types. And why is that not working? Because we are not returning that in every instance. That's totally fine. We're going to work up to that. Now, if there is a user, we want to find out, does this user have an existing API key? And we do this by saying const existing API key is going to be equal to await, and then db, we're going to import that, dot API key, dot find first, and we want to find the first key where the user has this key and it is enabled. So we can say where, pass an object, user ID is equal to user.id, and then enabled should also be true. So does this user have one valid API key? And if there is an existing API key, then we want to return an error, right? We cannot create an API key, what we're trying to do in this route, if the user already has one. That doesn't make sense. So we can return a res.status 400.json. And then here we can say as an error, you already have a valid API key. And then if I hit Control and Spacebar, you can see, oh, you can't see that. Well, okay, never mind. I wanted to show you something cool, but it didn't work. And then as the created API key, we want to return null. Just forget it. Let's just continue on. Okay, and now if there is a user and they don't have an API key yet, Jesus Christ, go away. Okay, if we have a user and they don't have an API key yet, then we're going to create one. So const created API key is going to be equal to await db dot create. Why is that not working? Oh, because we need to define what we're creating first. That's going to be an API key. So db.apikey.create. And we're going to create it with the following data: a user ID of the current logged in user.id. And then for the key, we're going to use, and I switched my keyboard accidentally. And for the key, we're going to use nano ID that we still need to import. And it doesn't give me the auto import. So let's say at the very top of the file, import nano ID from nano ID to generate that ID. And I think I wasn't able to show you what I meant earlier is because the type import didn't work. Yeah, so when I hit Control Spacebar, you can see what we still need to pass to satisfy this API response that is always of the type we have defined right here. So essentially we're saying we're always going to return an error and an API key, whether that's null or an actual API key. So for the API key right here is null because we didn't create one after all. And then as the key for this API key, we're going to invoke nano ID, but that doesn't seem to work. Is that a named import? Yes, it is. And now we have successfully created the API key and we can return that to the user. So let's return a res.status 200 successful.json. That is going to contain an error of null and also the created API key that we've just made for this user. Great. Now the only thing that's left to do is handling an error, and we can check if the error is an instance of z.zod error. So let's import z from zod. Now in this case, this would never be the case, right? But it would be if we did some schema validation with zod. That's why we also want to implement this checking right here, because you're going to see in the revoke route, that's exactly what we're doing. And if you wanted to extend this API route, it's just, so both are equally created. As you can also see in the types, both have an error that could be a zod issue. And that is just handy for expanding on this later. But you're going to see exactly what I'm talking about when we get to the revoke route here in a second. First off, let's finish up the create API key route. We're going to return a res.status 400.json, and then here we're going to pass an error of error dot, and because we checked the type of the error, we know what this will look like with Typescript. Super handy. We can pass the error dot issues, and then the created API key is going to be null because we failed to create it. And then if it is not an instance of a zod error, it is some unknown error, we're going to return a res.status of 500.json. And here we can pass the error as something very generic, like internal server error, and then the created API key that we promise to always pass because of the type is going to be null. And there's one last thing, because right now someone could make any request to this route. They could make a get request, a post request, put, delete, patch, whatever, and this would always run. We don't want that to happen, so we're going to create one super helpful utility function that is going to be called with methods. So let's go into our lib folder and then create, actually let's close all, let's go into our lib folder, then let's create a folder called API-middlewares. And here we're going to create a folder called a file called with-methods.ts. This is going to be pretty simple, essentially allowing us for every route to wrap this handler in a with methods that we can then call, pass it in array of the methods we want to allow. In this case, that would be post, and then pass the handler, essentially protecting this route from everything other than the requests we want to happen. Now to write this middleware, it's rather simple. Let's export a function called with methods from this file. That is going to get methods as a actually no, that's going to be a string array. So either post, put, patch, delete, whatever the methods are. And then also a handler, and we know the type of the handler. If we hover over this, no, if we hover over that, it's a next API handler. I'm not quite sure why it didn't show that, but we know the type. It's a next API handler. And now we can actually handle the logic that should happen inside of this function. So from this with methods, we are going to return another function. This is going to be asynchronous, async function. And that function is going to be an anonymous function, so it's not going to have a name we're just going to create it like that with a rec, and it's going to be next API request, and then a res, a next API response. And you see the similarity here, right? The handler has this, and this also has the same. And inside of this anonymous function, if there is no request dot, and is VS Code loading? Oh my god, it's loading once again. I'm having a great time with VS Code. It's a lot of fun, and I think the software VS Code is based on is very good. Oh, it worked. Okay, so we still need to import these types. And now we can check if the rec.method does not exist, or if the rec.method, no, we're gonna type that or write that differently. If the if not methods dot includes the rec.method, rec.method, then this is an invalid request. So if whatever methods we pass, so for example the post we've passed right at the bottom here. In our case, for this API route, this would be just the post. If the methods did not include that post notification, then that is invalid. So we're going to return a res.status, then 405 for this method is not allowed, .end. And otherwise, this is a legit request. So we want to return, actually, let's do that before, return the handler and just pass on the rec and res. And let's format that. And once again, VS Code is back at it and still loading. So I'm not sure if I did any type mistakes here. I'm pretty sure I didn't, but VS Code wouldn't show it right now because it's still loading. Let's give it a hot second, and I'm gonna be right back when it's finished loading. Oh, never mind. There we go. It just finished loading. Great. Okay, let's save that. And also we need to import the with methods in here. And we are good to go. That's the create route for an API key done. And now we can actually create API keys. That's pretty dope. And we can try that out in the browser right now. So let's move this over to the side. Let's click on, let's reload the page first. Let's click on request key. And it says unexpected end of JSON input. Let's see what happens. Can we see anything in the browser console? Class name did not match. No, that's not what we're looking for. I'm gonna dig into this and then be right back. Okay, I think I figured it out. This should not be a post request, but a get request. After all, a post request to create an API key doesn't make too much sense if we're not even expecting data from that. So let's see if that works. And that did work. It generated an API key. Very, very nice. So we got that done. And now we can close this down, and we can close a bunch of files. Let's close all. And let's see what we're going to do next. So we've got the creation done. Now if we reload this page, you should see that not the same page is getting re-rendered, because in the dashboard component right here, we can see if there is an API key, then we're rendering the API dashboard, and only if there's not, we're rendering the page we were just on. So right now we're rendering a completely different page, the API dashboard. So now I think it makes sense to actually finish up this project with the API dashboard and one last API route, the actual functionality that we can request with the API key, which is going to be the text similarity. Also a pretty simple API route. So in terms of project progress, I'd say we're 80% done and 20% left to go. And that 20% is going to contain some really cool stuff that I think is really going to benefit your learning. So let's continue with the API dashboard. And this is going to be a pretty simple component with 2 new components that we haven't done yet, but the rest is going to be very familiar to you. So let's start this by declaring this as a server-side component. We don't need all of this stuff. This is going to be server-side. So let's mark this as asynchronous so that we can then work with it. And the page.tsx throws an error. That is completely fine. We can just mark this as / for a comment, and then ESLint, or actually no, it should be at TS expect error server component. As I said earlier, they're still working to resolve this with the Typescript team. For now, we need to mark this as TS expect error. Everything is fine with the component itself. There's nothing broken with it, nothing wrong with it. We just need to keep that in mind. And now let's get started on the API dashboard. The reason we mark this as a server component is now we can request the user data. So const user is equal to await get server session. You already know the drill, auth options. And then if we don't have the user, we can say not found. Just call that arrow function. When used in a React server component, this will set the status code to 404. When used in a custom app route, it will just send a 404 status. So we're saying redirect to the nearest arrow page, basically. Okay, let's get the API keys for this user. Const API keys. So all API keys this user has ever had, not only the current valid ones, are going to be equal to await db.api key.find many, because we want all of them. And then we want all of them exactly where the user ID is the user.user.id. Great, so now we have access to all the API keys this user has ever had. And we want to get the active one as well. That's going to be const active API key. It's going to be equal to API keys.find for each API key. We want to check if API key.enabled. Because there's only going to be one matching that criteria. We've made sure that is the case with Prisma unique. So it couldn't happen that there are multiple enabled active API keys. And if there is no active API key, we are gonna invoke the not found once again, because if they're on this page, that should definitely be the case, right? After all, they don't even get to the page if there isn't an active API key. So this is just for TypeScript, basically to know that we can be sure there is an API key, because TypeScript doesn't know about the other page, right? And then const user requests, we want to find out all requests this user has ever done with their API keys. It's going to be equal to await db.api requests.find many, and we want to match certain criteria, being where. And here we're going to pass the API key ID. And then we're going to do something interesting. We want to check every key this user has ever had, right? And we know the API keys this user has had. So with Prisma, we can say where API key ID in all the API keys this user has ever had. We do that by saying in and then API keys.map. And for each key, we want to return the key.id, essentially creating an array of all the key IDs that this value should be in. And then we have access to all the user requests. And by the way, if we take a look at the Prisma schema, each user request also involves a timestamp. And because we're about to pass this user request object or array down to another component, we want to make this serializable, because by default, dates are not serializable, meaning we can't pass them on. So we're going to create a const serializable, and I changed my keyboard again by accident, serializable requests is going to be equal to user requests.map. And for each request, we are going to return an object implicitly. That's why we have this syntax right here, to right away return an object instead of having to write this, return that. We just can save this return statement by wrapping this in the I think it's called parentheses, right? In the round brackets. And then we're going to spread in the request, but we're going to change the timestamp to make this serializable. And for that, we're going to import the format distance from datefns. Again, the import doesn't work. No idea why. Import format distance from date-fns. That is a super convenient library to work with dates if you've never worked with it before, essentially turning a Unix epoch timestamp or whatever this is into a human readable format, like 1 hour ago, 1 minute ago, and so on. And here we're going to pass a new date that is going to be initialized as the rec.timestamp. And then as a reference date, we're going to pass the date right now. And you're going to see what that looks like in the final table. And now the serializable requests we can actually pass on to the table component to render that out. Okay, so for the JSX on the API dashboard, it's going to be pretty familiar to you. Most of the components, the class name is going to be container, then flex column, and also a gap of 6 we want to give to this to the elements in the flex. And first one is going to be a large heading. There we go. You already know that one. That is going to say welcome back, and then we can get the user.name from the login data that we get from NextAuth, just to greet the user. You know, it's always very nice. And then pass a div in here with a class name of flex column as well. And medium, that's going to be a flex row with a gap of 4. We're going to justify that content to the center. And on medium devices and upwards, we're going to justify that at the start. And then also last thing, we want the items to be in the center always. Great. Now inside of this div, we're going to pass a paragraph. You already know that as well. Paragraph as saying your API key, and then colon. And then after that, we're going to pass the input. You already know that as well. That's going to be self-closing. And as a class name, this is going to get the width of fit and then a truncate, meaning that any text that goes beyond the input border will be replaced by ... and not look, it just looks better. This input is going to be of type read-only as well. And the value is going to be the active API key .key. .key meaning the actual value. Otherwise, we could pass like the ID, the user ID, whether it's enabled or not. But we want the value of the key. So we do that by saying .key. And then in here, we want a couple of options in a second. But let's just render that out for now and see what that looks like. Let's refresh the browser. And that looks great. Welcome back, Wordful AI admin, your API key. And then it lists my API key down here. And we want a couple of options for this API key. We want to copy it, revoke it, and also generate a new one. We're going to implement that in a second. Let's mark that as a comment for now. Like right here. And why is this not working? There we go. Add options to create or revoke. And that should be create new. We're going to do that in a second. First, let's finish up the rest of this component with the paragraph right here. Another one, paragraph, saying your API history, and this is where the table is going to come in. And this paragraph is going to get a class name of text-center, medium text left. So on desktop devices, we want the text to be left side with a margin top of 4, and move this to a minus margin bottom of 4, just to offset this a little bit to make it look nicer to the eyes. And maybe I can expand this just a little bit. Yeah, there we go. And now we can create the table. The table looks super complicated, but in reality, it's a rather straightforward component if you know which libraries to use for it. So the table is going to take, actually, let's just create the table first. Doesn't exist yet. So let's go into our source and then components. Let's create the table.tsx component. And the table is going to allow for super cool functionality, but obviously we're not going to do that ourselves. That would be super much work, but we're going to rely on a package that allows us to do all that super intuitively. For that package, first we need to define the columns. So let's say const columns is going to be of type grid call def. By the way, this grid call def is not something we write ourselves. This is a type we get from material UI. So import type grid call def. That's just going to make it a bit easier to work with this. We get that from material UI from the data grid from at MUI/xDataGrid. That's where we get that type from. And that columns is going to be equal to an object. Now that is kind of metadata. Oh, and this also needs to be an array. And this is metadata because it doesn't, we're not returning anything. So we're missing properties and we're going to add them right now. So let's pass, that needs to be an array, not an object. And then we're going to pass an object as the first property with a field of column 1. Then as the header name, we're going to say API key used. That's going to be the column to list the API key that was used for this particular request that we're displaying to the user. Then a width of 400 and also a render header of params, allowing us to make this bold and also add an emoji. which is not necessary. I just found it cool. And then returning a strong. So for strong, bold HTML text, that's what this semantic HTML is for, with a class name of font-semi-bold to make this a bit bolder. And then we can say params.callDev.headerName. So that is just the original header name. Say we named this column API key used. That is what this value is gonna be equal to. And then we can also add an emoji at the end if that's what we wanted to do. You could leave it out if you don't want it, and that is totally fine. Then as the second column, we're gonna pass a field of call2, a header name of path, and then a width of 250. And now we can just copy this down 1, 2, 3 times, and then change each column subsequently to call 3, 4, and 5, and then change the second one to recency and a width of 250. That can stay. The third one is going to be duration and a width of 150 because it's a very small number. And the last one is going to be status, and that is going to get a width of 150 pixels. Great. However, I intentionally named this columns so you get the gist of it, but we still want to modify them just a bit because we also want each of these to be bold, right? However, it would be kind of useless to include this render header for each of them if we could just map through them and do this for each. So let's do this and let's rename this as, I think, yeah, columns draft. So that's the initial draft of the columns. And then for the actual columns, let's say columns is going to be equal to, and then columns draft dot map. And for each call, we are going to execute the following function. So if the call dot field is triple equal to call1, then nothing should happen, right? It's already bold because we've already included the render header for the first column. We want nothing to happen, so we're just going to return the call early. And if it's any of the other columns, so one of these 4, then we're going to return the call, just spread it in, but we want to make the header name bold, right? Just like we did with the first one. So we can literally copy and paste the render header down here, and the params will be of type grid column header params any as a generic. I don't know what this means. I mean, I don't know, honestly. This is just a type we get from Material UI for some type safety. We don't need to know what it means. We don't need to work with it. It doesn't really matter. We can just fly with it as it is. And that's the columns done. Great. Now we've got the columns for the table. The rows will be supplied to us by our database. And now let's get to the actual component because we haven't even done that yet. So let's initialize this as a functional component, a table right down here. We can move the import statement all the way to the top because that's where they usually go. And then for the table props, this takes the user requests, right? We want to pass the user requests from the API dashboard down to the table. Now the type of these user requests is going to be a bit tricky because remember we replaced the timestamp to be serializable, right? And we need to accommodate for that in this table component. And the way we do that is with a little Typescript trick. We can define the user requests as modified request type and pass that a generic of timestamp because that's the one we modified. And that is going to be an array anyways. Now this type is not something we can import. It's going to be one we define ourselves right now. And this type of modified request type takes a generic. I decided to name that K. That extends to the key of API request. Now don't worry if this looks complicated for now. Essentially we're saying that this generic we decided to name K takes all the properties that an API request that we get from Prisma client normally has, right? So that would be all of these properties right here. And now we want to change one of these. So we can say omit which is a general utility function we get from TypeScript. We don't even need to import that. It's super useful. It takes two generics, first one being the API request. And you can see what the function does here. It constructs a type with the properties of T, so the API request, except for those in type K. So what we're about to pass right now, also named K. And then an object that we want to modify, and we want to modify the timestamp to be a string. Now this is a little bit of more advanced TypeScript. Don't worry if you couldn't fully understand it. It's not a huge issue. It's gonna appear very rarely in your React projects that you actually need to do this. It's just useful if you have to serialize the value and want to modify one type of that. Okay, and now that we've done that, we can get started with the actual table component, which is not gonna be super difficult because we rely on the library for the most part. First, we want to know the theme of our application. So let's call it theme application. Let's call it application theme. And as you might know, we get that from use theme that we get from next themes. We can destructure that, and that will be useful for determining the theme of the table. So we can say const dark, or we can just say const theme is going to be equal to create theme, which is something we can import from, and we can import this from system or material, but we want to import this from material, MUI/material. That's where we want to get the create theme from. Invoke that, pass it a object, and inside of here we can pass the palette option. That is going to take a mode of, and if the application theme is equal to light, then we want this to be light as well, and otherwise we want this to be dark. And there we go. Now one last thing we need to do is, before rendering the actual table from Material UI, is determining the rows, which is going to be super simple. We can say rows is going to be equal to user requests dot map, and for each request we want to return implicitly the following object with an ID of request dot ID, a column 1, and these need to match whatever we've defined up here in the columns, by the way, with a column 1 of request dot used API key, because that's the API key, like the value that corresponds to that column. For the second column, we want to pass the request dot path. For the third one, call 3, we want to show the table to show a template string containing the request dot timestamp that we've already formatted, and then ago. So this would be like 1H or 1M, 1S. So for 1 second, 1 minute, 1 hour ago. Then for the fourth column, we want to also pass a template string with a similar principle. We want the request dot duration and then ms for milliseconds. And then lastly, for the fifth column, the status column that we created, it's going to be the request dot status. And those are our rows. Now the actual data grid is going to be pretty straightforward. First, we're going to pass the theme provider that we get from MUI/, and that should also be material. Yes, we can import it from MUI material with a theme of theme that we've determined right up here, and close that off. And by the way, because we're using a provider, there should be a client component. Use client like that. Because we're providing context, and that can only be done in client components. Then in here, let's render the data grid, the big component data grid with a style, a little custom style of background color. And then if the application theme is equal to light, then we want the background color to be white, and otherwise we want it to be of type #152238, a hex value, and we want a font size of 1 rem. That's all the styling we're going to apply to it. We want a page size options of then this object notation, then pass an array of 5, so 5 listings per page, and then the pagination will start. We want to disable the row selection on click. It's going to have an auto height, so all the content is automatically shown, and an initial state that gets passed an object with a pagination property, nation property with a pagination model that also takes an object with a page size of 5. Now that was pretty quick. You can take a look at that. And also obviously in the material UI documentation. I'm not making this up, I swear. It's also in the MUI documentation. Now we imported that, great. And the last thing this needs is the columns and the rows. And since we've done all the preparing already, we can just pass the columns and then the rows will be equal to the rows and we are golden. Great, now that can be self-closing. And now we can import the table from ./table and also pass that the user requests. And that should be the serializable requests and not the actual user requests. And there we go. Let's refresh the page and see what happens if this works. Hopefully it does. Let's reload that. And the server should still be up, right? Yes, the server is still up. Let's give it a hot second to reload. And it shows the table. Beautiful. So if we go into big mode, you can see the API queues, the path, recency, duration, and status. And then all the values will be shown in here. Now we haven't done any request yet, but this is where the values will go. Okay, just to summarize, we're pretty far into the project. We've got a beautiful light and dark mode. We've got the API key functionality working. It does generate. We've got the table, which is a huge important part. We've got the homepage done. We've got the documentation page done and animated and mobile optimized already. And we have got the dashboard both for when you already have an API key and for when you don't have an API key. And the sign out functionality, it does work. What we haven't done yet is protected the sensitive routes. That's what we need to do. Also, we need to create one API route for the actual service, rate limit that API route, which is going to be very straightforward. Don't worry about that. And then we're almost done. One thing we didn't do for the API dashboard yet is this add options to create new or revoke yet. And let's add that right now. And let's get that over with. And let's create a component called API key options. Let's call it that for now. And because we already got the drop-down menu, this is not going to be too hard as well. So let's go into the components and create that API key options.tsx. And create this as a functional component that we can then already import here. Now, the drop-down menu is going to come in really handy. So let's render out a drop-down menu from the UI. You can close that for now and also go into the side view again. Like that, great. And then inside of the drop-down menu that we're creating right here, we want a drop-down menu trigger. Also from the UI, we can say add/UI/drop-down menu, looks a bit better. And the trigger is going to be disabled when we have set some state. So inside of this component, we want to initialize a state that is going to be called isCreatingNew. So are we currently creating a new API key for this user or not? And that is a Boolean that is going to be false by default. Now, remember, because we're using functionality like state, we also want to mark this as a client component. And now, we also want one more state. We can just copy this down and then call this isRevoking and then set isRevoking. So are we currently revoking the API key of the current user, which is also going to be a false Boolean. And now this trigger should be disabled if one of these is true. So we can say isCreatingNew or isRevoking. If one of these is true, the trigger will be disabled. It just makes sense. The user should not be able to click that when an action is already being processed in the background. And then as child, because we want to pass a button here and avoid the dilemma of having two buttons inside of another and provoking a hydration error. Now this button is going to be of variant ghost and then have a class name of flex gap-2 and items-center. Inside of this button, we're going to have a p tag and do some quick and dirty nested ternary statement. So if isCreatingNew is true, then we're going to say inside of this button creating new key. Otherwise, if isRevoking, Then we're going to say revoking key. And if none of these are true, we're going to say options. So we're going to present the user with the options, and that should be is creating new. There we go. Nested ternary statements are generally a no-no, but I think in this case it's really easy to read and it's not a huge deal. So we can go with it. And then if is creating new or if is revoking, then we can render something specific, or else we can render null. And what are we going to render? A loader 2 that we get from Lucid React as an icon, and we're going to give that a class name of animate-spin, height of 4 and width of 4. So we are indicating visually to the user that the current state of the application is loading. And then we can get to the content, right? We can begin with the drop-down menu content that we also get from the same component. And inside of here, we want a drop-down menu item. Drop-down menu item. Also from the same component, of course. And this item is going to receive an on-click handler. On-click, and what that on-click will do, you'll see in a second. When we worry about what should be in this item, that is going to be copy. So that's the text that is going to be inside of the item. If we take a look at that in the inside of the dashboard, we need to sign in first to get to the dashboard. Let's do that right now. And okay, I think it just hot reloaded while it was signing in. If we take a look at the options right now, we see copy right here. That is what we're building. And you can probably guess by now what this drop-down menu item is going to do. It's going to copy some text into the clipboard. So the navigator.clipboard.write text is going to be called with the API key. And I just called this API key. It's kind of a weird naming, but I think it's the most fitting considering how we named the API key, because this API key options demands two things to be passed to it. That is the API key ID that we can then work with in revoking the API key, and also the API key. You can name this differently if you would like. Okay, so let's call the API key ID a string, and the type of the API key is also going to be a string. The API key, if you don't know what I'm talking about, is just the literal API key that is being used to make the requests to the endpoint. That's what that is. Great. And now that we copied the API key, we can let the user know we did that by emitting a toast notification with a title of copied, a message of API key copied to clipboard, and then a type of success. Oh yeah, great. Then we want one more, actually two more items, but they're going to look a bit easier. Drop down menu item like that, and in here we're going to say create new key, and we can copy and paste that once more to say revoke key. Format that. Great. And now we also need to pass the values we expect in the API key options from the API dashboard. For the API key ID, we're going to pass the active API key.id. And then for the API key, we're going to pass the active API key.key. That's what we're going to pass to the API key options. By the way, we can close a bit of this stuff again. And then let's see what we did. So when we open up the options, we can see copy, create new key, and revoke key. However, these two don't do anything yet. And let's do the create first. That's going to be super simple because we've already, remember, create API key. We've already defined the utility function, and now we can just use that inside of this component. So let's create a function called create new API key. Const create new API key is going to be an async arrow function, and in here we're going to say set is creating new to true, because we always want to indicate a loading state, and then in here goes a try catch block. Now inside of the try, we're going to say await revoke API key, and then in here we're going to pass the key ID of API key ID. Now this revoke API key is also going to be a utility function we're going to create right after. and then await create API key, just call that utility function we've already created. And then we're going to say router that we get from next/navigation. We can say import router from next/navigation. And that is why is that not working? Oh, this needs to be the use router. And then we're going to initialize the router as const router is going to be equal to use router here in our component. And with that router, whenever we have revoked the API key and then created the API key, we can then refresh the page. So we can say router.refresh. And by doing that, we avoid having to put this somewhere into state and then display it to the user again. We can just refresh the window and do it that way. And then also have the API key, the API dashboard as a server component that doesn't need any state because of this statement right here. Then if the catch statement gets called, then chances are something went wrong. We want to let the user know by saying the title of error creating API key. Then a message of please try again later. And then lastly, we want to pass this as a type of error. So the user knows what's going on. And then that goes right here. Finally, we want to set is creating new to false. Okay, here we are back. It's a new day for me. You probably didn't notice any change. It's probably only been a couple seconds, but for me it's a new day. And we were in this file right here doing the revoke API key functionality. And to do that, let's go into the source folder, and then we can find the create functionality and just create it in the same folder. So let's call this revoke API key.ts. And inside of the revoke API key, we're going to write the function that is going to invalidate an API key for a user. So let's export an async function from this file. Let's call it revoke API key. Now this function takes a key ID, and we could write out the key ID not in this object syntax. However, when we do, and then when we invoke the function, we always know the parameters that get passed, and I just prefer the syntax. And because we only expect one argument in this function, we can also define the type inline doing this little object syntax right here, where we have the object, then a colon, and then the same object with the same property, and then the type of that property. In our case, that's going to be a string that we are expecting to be passed into this function. And then we can say that the const res for response is equal to await fetch, and now we're going to fetch from the revoke endpoint and pass the key ID. So the endpoint is going to be hosted at /API/API-key/revoke. And I think we created that together yesterday. No, we didn't yet. Okay, but we are going to create that then in a second. And then this is going to be a post request. So for the method, we're going to pass post, because after all, we also want to include the key ID, right, that we need to invalidate. And then for the body of this post request, we are going to pass JSON.stringify of the key ID. So we receive that on the server route. And then for the headers, one last thing, we want to pass the content-type header, which is going to be application/JSON data that we are sending along to the API. And that is the request done. Now we are going to get a response from that endpoint that we haven't defined yet, but we can call this data. And this data response will be the await res.json. So whatever we get back as a response, we're going to turn into JSON. And of that, because if we take a look at this right now, this is any, we don't know the type of this. And now we're going to cast that as a type again, as error, and that is an optional string. And there is a little syntax error here, so we need to write as for that to work. So either we get back an error or we don't get back an error. And if we do, we need to handle that. So if we have a data.error, then we're going to throw a new error with that data.error like that. There we go. So we can catch that in the try catch where we revoke this API key. Specifically, that would be in this catch right here, where we then render out a toast notification and properly handle this error. Great. Let's go back into this file and save the revoke API key. And now let's go back into the API key options and import this function, and that we pass the key ID. Now everything works fine. However, the create new API key is never called. And remember, we want to call this for the drop-down menu item. So we can pass an on-click handler to this drop-down menu item, saying that we want to create new API key, that function to be called whenever we click the drop-down menu item. And then for the revoke key, we also want to pass an on-click handler. This one is going to be even simpler than the create new API key because we are just going to call the revoke route inside of a try catch. Let's call this revoke current API key, and also define this function up here because we haven't done that yet. Let's do it below the create new API key. Let's call this revoke current API key. It's also going to be an async function. And we're gonna also do this with a try catch. So first off, we want to set the is revoking state to true, same as with the is creating. And actually we can just copy paste this whole try catch block and paste it in here. And then we still need to remember to change the state of is revoking. Let's set the set is revoking to true. Then we've got the whole try catch block, but we don't need to create a new API key. We can just await the revocation. I'm not sure how that's called, but we can just await this revoke API key function and then refresh the router. So the page will be reloaded and we save ourselves the hassle of handling this in state. And I think we are almost done with this. Error revoking your API key instead of error creating your API key. And yeah, that works just fine. And now we also need to set the is revoking to false instead of the set is creating new to false. And we are officially done with the API key options. And let's take a look at what that looks like in the browser. So let's go to our dashboard like that. We are already signed in, so we don't need to do that again. And let's go to options and then revoke key and see what happens. It says revoking key and now it says error revoking key. Interesting. So that shouldn't happen. The server responded with a status of 404 not found. Okay, yeah, that makes sense. So we did try to call the API route. However, that API route does not exist yet, same as for the creating an API key. So I think it makes sense logically to work on these API routes next to actually define those. And to do that, we're going to go into source and then pages at API. Then let's create a folder inside of API called view1. Now this is just a best practice in naming your APIs after versions. So even if you decide to make new versions of the API, users can still use the legacy, the old versions of the API. It's just a good practice to do that. And then let's create a create.ts route inside of the API. And we're going to do that at the API key, and then the v1 is going to handle the actual functionality, the similarity check that we want to do later. Anyways, before we get into that, that folder creation was kind of unnecessary. We're going to worry about that later. First, we want to go into our API-key directory. And then here, oh, we've got the creation route. And now we also want the revocation, I think it's called. I'm not too sure. The revoke. So let's call this revoke.ts because we're going to revoke an API key. And once again, VS Code is super slow in creating this. So yeah, I'm just going to enjoy my coffee and let's give this a second and wait for this to finish loading. Great, it has done the thing. And now we can get started in this server-side API route. Let's call this handler. So const handler is going to be equal to an async arrow function that we do like this. And this arrow function, as always, is going to get a rec as a type of next API request, and then a res of type next API response. And we need to import both of these from next. And now we can get started with the actual logic of this API handler. However, before we do that, let's export this handler as default. handler. And also we want to wrap this handler in the with methods middleware we have created. With methods, and don't tell me VS Code is doing it again. No, dude. Oh, Jesus Christ. Okay, let's give it another second to load. And then the auto imports should work. There we go. Okay, now we can import the with methods, invoke that, pass it an array. And then we want to make a post request to this API route. That should be the only one possible. And then we can pass the handler as the second argument into that function. Great, so now we can only make post requests to this route, and now we can handle the logic that should be applied to revoke an API key. First off, a user needs to be logged in. So let's say const user is equal to await get server session, and to the server session we can pass the request, the response, and the auth options that we have defined in the lib/auth. Great. And let's sneak in a quick and dirty .then. We get the response back, and we want to return the res.user if that exists, obviously. And then we either have a user or we don't. And if we don't have a user, then we want to not allow them access because they're not logged in after all. In which case we're gonna return a res.status of 401 unauthorized.json, and in here we're gonna say error unauthorized, and then a success value of false. Now what we also want to do is pass this next API response a generic, just like we did in the create route. Remember, when I go back to the create API route, we pass a generic of create API data. And because we've already done the types, we can see right here, we've also got the revoke API data that we want to pass as a generic right here in the API route. And also import that, but that doesn't work again. So let's say import revoke API data from add/types/ and I don't think we have a types route. Let's go into the TS config to check that if we have configured a types route, and we did not do that. So let's do that really quick. Let's say add/types/anything will map to ./source, and that needs to go into double quotes ./source/types. And let's see if we can import the types from add/types, because this is an index.ts that might just work. And let's restart the type server to check that. And this needs to go into /API as well. So add/types/API. And then it should be the index.d.ts/index.d. Now, I don't think we need that actually. Okay, there we go. I just deleted the line and now the imports work for some reason. I don't know. Sometimes, why is this not working now? Cannot find more. Bro, you automatically imported it from there. And now you're telling me it doesn't work? Oh, probably because we forgot the /star in the tsconfig.json. So if we go into type/API, we also want that to map to the corresponding file path in our project. And I really hope that will work now. Yes, it did. Great. Okay, we got that to work. We've got the revoke API data right here in our handler. And now we can continue. So we have a user, right? We've got the guard clause right here that checks if we don't have a user. Now we can assume that we have users. And so now we can find the existing API key for this user. Or we could call it valid API key is equal to await db.API key. And we want to find the first API key where, and you probably know what we're going to do right now, where the user ID is equal to the user.id that is currently logged in, and then the enabled property is true. That's what we want to check for. And if there is no valid API key for this specific user that is currently logged in, then we want to return a res.status of 500.json and let the user know as an error message. Now we get type safety, by the way, if you look at this, and because we passed the revoke API data as a generic to the next response, we can see which values we need to return from this handler, which is going to be the error. And this is going to say this API key could not be revoked. And then as a success property that we also need to pass, obviously, we are not going to pass true, we are going to pass false as the success. And now, if we are through these guard clauses, we know the user is logged in and they have a valid API key, in which case we can actually revoke that API key. That's invalidate API key, like that. And let's handle the actual logic for that. So that's going to be await database.api key.update. And we want to update the API key where the user, where the ID of the API key is the valid API key.id. And then what exactly do we want to update for this API key? That's going to be the data of enabled, and we want to set that to false, therefore invalidating the API key that the user currently has. Because remember, we're only checking for the enable true property when it comes to a valid API key. And now everything was successful. We can return a status of 200.json, and then here we can say that the error should be null and the success value should be true to let the users know that this request was successful. Now, because we wrapped this in a, no, we did not do that. Let's wrap this entire thing in a try catch because we're handling async logic. We should definitely wrap this whole thing. Let's cut it, initialize a try catch block and paste this inside of the try. And if there's an error at any point now, we can handle it right here in the catch part. And let's handle the error the same way we did in the create route by first checking if the error is an instance of z.zod error. And to check that, we also need to import the z from zod. Let's go up to the top of the page and import that. Import z from zod. And now we can check if the error is an instance of a specific zod error. And if it is, then we want to pass or return a res.status of 400.json, telling the user with the error property what the problem is. And we are not going to write this ourselves, but we're going to get this from Zod. That is the handy thing. So we can say error dot, and now because we did the type checking, we know this is a Zod error, and we can assume these properties exist. So we can say the error dot issues, and as a success property, we are going to pass false, obviously, because we're in the catch block and error occurred. And then if this is not a Zod error, if it's an unknown error of some sort, then we are going to return a res.status of 500.json, telling the users as an error message that there was an internal server error. And then as a success property on this error, we want to pass false because the request was unsuccessful. Great, and that is our revoke route of the API done. We can save that, and now we can try to revoke this API key. Let's hit the button. It says revoke an API key. And yes, sir, it worked. We're on the other page because we refreshed the router. And now we are on the same page as if we never had any API key in the first place. Great work if you're following along and are at this point as well. Really, really good work. We've gotten really far. And I think the only thing that is left to do is handling the actual API key logic when someone makes a request to our main API key route. Okay, and I just noticed one thing that is not really necessary that we're doing, by the way. When we are going into the revoke API key.ts route, we are passing the API key ID to this endpoint, even though we don't even need to do that. So technically, we are not receiving the key ID anyways. And I think I'm going to change that in the GitHub repository because this is totally unnecessary passing that. And that is just one thing that I forgot in this code. So technically we could just change this to a GET request and, save us this whole passing of the key and then change the create API key to a GET request. I think that would make a lot of sense, even though then that would be vulnerable to a cross-site request forgery. Because if you don't know the authentication cookie, if we take a look at this application under cookies and then localhost, the authentication cookie, the next auth session token, this is what brings us the server-side session, right? So we can check if the user is logged in. with this cookie right here. If you take a look at the same side property, it's set to lags, which means that on GET requests, this is also sent along even if the GET request originates from a third party. Whereas with POST requests, this is not passed along. This is like a bit more advanced of web security. Essentially, if we turned the revoke API key to a GET request, which we definitely could because we don't expect any data in it, this cookie would be passed along even in a request forgery from a third-party domain. I think that's not a huge security risk in our application specifically, but just keep that in mind. If you decide to change this to a GET request, you might as well leave it a POST request without passing any data. That would work as well. And I'm gonna figure something out for the final GitHub repository. Maybe just leave it like this. It's not too bad in the first place. I just want to mention that, not to confuse you though. And now let's get started in the similarity route to handle the actual logic for our API route. So let's go into the v1 folder that we already created previously. Let's close this down and close that down. And in the v1 folder under pages/API/v1, we are going to create a new file called similarity.ts. This is going to be our main endpoint. And from here, you know the drill. We're going to we're going to declare a const handler. It's going to be equal to an async arrow function. And at the very bottom, we're going to export this handler as a default. So export default handler. And again, we're going to wrap this handler in our with methods API middleware. Oops, I activated caps lock. With methods, import that. And the method that we want to allow for this route specifically is a post request. And then also pass the handler along, so we can only make a post request to this route. Now we're gonna do some interesting schema validation with Zod. If you've never done that, don't worry. I'm gonna explain every step of the way, and it's not complicated at all. So first off, let's import Z from Zod. And what this allows us to do is define a schema of the request that we accept, right? So we can say the const rec schema is going to be equal to z.object. Now, if you don't know what a z.object is, essentially, we are creating a schema to then check the input that comes in. So because we can never trust client input, we don't know what sort of input we are going to get for this post route, right? Somebody could pass anything as a post request to this API endpoint. And now we want to make sure that the data that we get is specifically what we define right now inside of this schema that we are creating. And that did a little typo. So we can say that we are expecting the text1 property to be there, which is going to be a z.string with a .max value of 1000 characters. So it can't be longer than that. And then we also expect a text2 property with a z.string that is also going to be a max length of 1000 characters. So if somebody passes like a text1, a text2, and a text3, for example, to this API route, which they very well could. If we take a look at Postman, for example, I've already prepared this API endpoint. If you don't know Postman, it's just a tool you can download to your desktop to simulate API requests. It's super handy. And inside of Postman, we can take a look at the localhost route, and we could pass along something like in the body of the request, text1, text2, and nothing is stopping us from also passing text3, right? But if we pass text3, we won't need that in our API route. So the schema is going to get parsed, and everything else that is not text1 or text2 is going to be removed completely. We don't need those values. And then, and then if text1 or text2 is not present, then this API route is going to throw an error because those are the values we need. And you're going to see what that looks like when we do the API testing. Okay, so let's have the const handler. And then first off, we want to destructure declare the body as the request that we still need to get as a argument in this function or parameter. I keep messing that up, as a next API request. And then the response is the next API not request as well. Next API response, and also import those types from next. Now we can say that the body is equal to the rec.body. By default, this would be any, but we want this as unknown. forcing us to properly, unknown, forcing us to properly validate the body with TypeScript. Now, let's get the authorization header, because when performing a request to this API endpoint, users always have to pass along the API key that they generate within our app. And to check that API key, we can say const API key that is passed to this route is equal to the rec.headers.authorization. Super convenient that we get this from NextJS. And then we can say if there is no API key, then we're going to return a res.status of 401 unauthorized.json and say error unauthorized. Unauthorized. Great. Okay, and now we can actually validate what comes in as the body of the post request with the schema we have defined above. So we can say const parsed, because these are the parsed values of the body, is going to be rec schema.save parse and then pass in the body. So the save parse does not throw an error if the parse fails. So if the text1 or text2 is not present in the request body, then the save parse is gonna not throw an error, but instead the parsed dot success value is gonna be false, allowing us to handle this error a bit better, in my opinion at least, because we can say if the if not parsed dot success, so if this did not pass correctly, if one of these values is not present, then we can return a res.status of 400.json, telling users that they did a bad request. And we can capitalize that. Okay, so now after this guard clause right here, we know that there is a API key. We don't know if it's valid yet though. And we know that the parse was correct. So we have a text1 and a text2 property in the request body. Let's enter a try-catch block now. And the first thing we're going to do is destructure the text1 and text2 from the parsed. So we can say const data is equal to parsed, and then we can destructure from the data the text1 and also the text2. And actually, to be honest with you, I'm a bit unhappy with this implementation. So I think what we're gonna do is delete this part, the parsed with the save parse and the parsed success. We're gonna delete that, and then instead we're gonna say the text1 and the text2 are gonna be equal to rec schema.parse body. So this is gonna actually throw an error that we need to catch in the catch block. So let's do that right away. And this is gonna throw an error of type zot error that you've seen previously. And we can catch that by saying if the error is an instance of z.zot error, which it will be when this right here errors, then we can return a res.status of 400.json telling the users that the error is an error.issues, which we know exists because we did the type checking of the zot error. And let's just finish up the handling for now. It's very fast. So let's also return a res.status of 500.json telling the users that there was just an internal server error if we didn't catch this as a zot error. As something must have went wrong somewhere and we don't really know what, because the error is unknown. Great, and now in the try-catch block we can assume that the text1 and text2 exists and work with that. So we can now check if the API key is valid. We have so far only checked if there is an API key present, but we also need to make sure it's valid, right? And we can do that by saying const valid API key is equal to await db.find first. Oh, and we still need to say .api key .find first, and we want to find the first API key where, and inside of the object brackets, where the key is the API key that was provided and where the enabled property is true, because that is a condition for an API key to be valid. And if we have no valid API key, if not valid API key, then in that case we can return a res.status of 401 unauthorized.json telling the users in the error message, so error colon unauthorized, like that. And now we can assume that we have a text1 and text2 property, everything that we need to work with, and the user has provided a valid API key, so everything is fine, and we can actually handle their request. And now to measure the duration of the request that we're gonna do, we're gonna initialize a start. It's gonna be equal to a new date, so we know how long the request has been running for, how long it took, so that we can display that in the dashboard to the user. And then let's create the actual embedding. So let's say const embedding. If you don't know what an embedding is, we're using OpenAI to turn text into a long array of vectors, like a long array of numbers, essentially a vector. And then we can compare the mathematical position of two vectors in the room. And the closer they are together, the more similar the text is. Now, this is not some super complicated math algorithm that we're going to implement. It's actually pretty simple. To create this embedding, we're going to say const embedding is equal to, and then await promise.all. Because we're going to make multiple requests, with promise.all, we can make them simultaneously at the same time. So we don't need to, for one request to finish before we can make the other, because one request does not depend on the other, which is super handy. So inside of this promise.all, we can destructure the text1 and text2. And it's not really a destructuring, it's more like we are creating an array from these two and then saying dot map. And for each of these, so for text1 and text2, we are receiving a text and want to run a function for each text. Now, because we are making an asynchronous request, we also want to mark this as async in front of the text. And then in here, we can handle the async logic that is now going to be executed simultaneously. And the logic that we want is const res is going to be equal to await. And now we're going to use OpenAI to create the actual vector for us. So it's going to turn the text that we have into a vector. And the way we do that is by saying OpenAI dot, oops, and we need to import that OpenAI. And we have not done that, so we still need to do that in the lib really quick. It's a very simple thing to do. Let's go into the source and then lib, and then let's create a file called openai.ts. And then let's say const configuration is going to be equal to new configuration that we get from OpenAI. That is the npm package we've installed at the very beginning of this course. And in here, we're going to pass the API key property, which is going to be process.env, and then whatever you call it in the env.example that you downloaded from the GitHub. This is called OpenAI underscore API key. And that is the only thing that we need to pass into it. And then we can say export const OpenAI is going to be equal to new OpenAI API, which is a class that we also need to import from OpenAI, like that. Invoke that and give it a configuration to the constructor. There we go. Now to get this OpenAI API key, let's go to the OpenAI website really quick, openai.com, and let's log in. And they changed the UI apparently. How can we log in now? Product, overview, no? All right, I guess not. Let's go back and search OpenAI login. And does that work? OpenAI? No, still doesn't work. Okay, so they made it super confusing apparently. Let's go to the OpenAI API page available under platform.openai.com. And now we can log in using Google. And I'm gonna log in really quick. You could use your Google account. Okay, so I've opened this up on my other account. And then when you have logged in, I'm probably gonna need to censor some of these values. We can go to view API keys. Then here you can see all the API keys that you have. And this is where you get the API key. You can just copy it from here, then close out of this window. We don't need this anymore. You can close that for now. Go back into our project in the env files, and then in here we can paste the OpenAI API key. Actually, you know what? I think it's easier for you if I just show you these values and then change them after the video. So I'm just gonna paste in my OpenAI API key right here. Save this, because we also still need to do the Redis URL as the last thing in this env file. paste in your OpenAI API key. We can close out of the env, and remember to restart your server because we redefined yarn dev redefined an environment variable, and now we can actually use the OpenAI value right here in our similarity route. So we can import OpenAI, and then we're going to say .create embedding, and this create embedding creates a vector from a text that is super useful for us. And for the model, we're going to pass the text dash embedding dash ada dash 002, which is just one model that does this really well and cheaply. And then for the input, we're going to pass the text that we're mapping over. And that's it. Now we can just return the res.data at the index of 0. The index of 0 dot embedding, which is going to contain the number array, the like 1500 length array of numbers that is representing the text as a mathematical vector. And then the similarity of these two texts are going to be in, or at least the vectors are going to be in the embeddings. So this is a number array. And to get the similarity of these two, under the promise.all, we can say const similarity is going to be equal to, and to determine the similarity between two vectors, we're going to use the cosine product. So the cosine similarity, let's call that cosine similarity. And here we're going to pass the embeddings at the index of 1, and also the embeddings at the index of so the first one is embeddings at the index of 0, and the second one is embeddings at the index of 1. Now this cosine similarity does not exist yet, and we're going to create that in our helpers. Let's close all of this, source, and then helpers. And here let's create a new file called cosine-similarity.ts. And this is just an algorithm to determine the cosine similarity. Let's export a const cosine similarity. This receives two values, the value a, let's call it, which is going to be a number array, and then the value b, which is also going to be a number array. And inside of this function, export function cosine similarity. There we go. And by the way, I don't fully understand this either. I just copy pasted this from Stack Overflow. I don't know how to calculate the similarity between two vectors, so I'm just gonna copy paste this from the GitHub. I think that's the easiest thing. Let's go into the github.com and then similarity API. Let's go back into here and then just copy and paste this kind of, I guess you could call it algorithm or whatever. There's no need to write this out ourselves. I don't fully understand it either. But essentially it returns the mathematical distance between two vectors, and that's all we need to worry about. Because as a programmer, as I mentioned earlier in the video, you don't need to understand everything. You just need to know how to Google well and then use code that is already there to your advantage. You don't need to write everything from scratch. You really don't. So we're just gonna paste this in there. We know this works really well. And now we can call the cosine similarity, import this, and the embedding, let's call this embeddings. There we go. Now we can pass the two embeddings as number arrays into the cosine similarity, and that will return a value from 0 to 1, 1 meaning the text is identical, and 0 meaning the text has nothing in common at all, which rarely happens. I don't know what you need to pass for that to happen. And now that we've got the similarity of these two, we can also calculate the duration, because remember we initialized the start. Now the calculation is done and we need to know how long this took. To determine how long this took, we can say const duration, let's call this, is going to be equal to new date. Let's invoke that, and then dot get time. And then from that, we're going to subtract the start dot get time. This is going to return to us in milliseconds how long this operation took. And last thing we want to do is persist this, right? We've got the API request model in the database. We want to know every API request that happened. So let's say persist request. And to persist this, we're going to say await db.api-request.create. And what API request do we want to create? We want to pass the data into here, and let's take a look at what this will look like. So first off, we want to pass the duration. We've already calculated that. We don't need to worry about that further. Then we want to pass the method of rec.method as string. And then we want to pass the path, which is going to be the request.url as string. The reason we're saying as string right here is because the rec.url could be string or undefined, but we know since this route is being run and we are at this point, they will always be determined, so we can assume that they exist as string. Then the status is going to be 200, because if we're at this point, it has been successful. The API key ID is going to be the valid API key.id. And then for the used API key that was used for this request, and we also need to put a comma here. For the used API key, we can say the valid API key dot key. That's the API key we use for this request. And then finally, let's return a successful status. Return res.status of 200.json. And as a response, we're going to return the success of true. Then the text1 that the user originally passed in, the text2 that the user originally passed in, then the similarity as well. Okay, so we've got that done. And I think our API should be working at this point. Let's try to make a request to this API endpoint without the authorization header. So in Postman, let's just take this out, but you could also mock this API request with a fetch in JavaScript if you don't have Postman, or you could download Postman, it's totally free. And let's try out making a request to this API endpoint. The URL we're going to enter is http localhost 3000 /api/v1/similarity. We are not going to pass an authorization header right now, but we are going to pass text1, text2, and not text3 for now. Let's send this request and see what happens. And the response that came back, I'm not sure how to zoom out. Can we just do this? No, that doesn't work. Okay, so I need to zoom out a bit. The error that came back is unauthorized because we did not pass an API key. If we write some bogus value into the API key and send that, the error is still unauthorized because this is not a valid API key. So let's go into our application and generate ourselves an API key. So let's sign out. Let's do the whole thing from scratch. We land on the main page, and then yeah, that needs to load a bit. This page could not be found. Wait, what? The dashboard could not be found. Well, anyways, we still need to validate. Oh, right. The page was not found because if there's no user on the dashboard, which would never happen if the route was protected, then we threw the not found error just in case. And we haven't protected the routes just yet, and we haven't implemented the rate limitation either, but that's going to be pretty quick in the middleware. First off, let's try generating ourselves an API key and making a request with that API key. So let's click request key. We've gotten a key. We can copy this value, put it into our authorization header. And now let's try making that same request, send that, and it said internal server error. That's not good. Let me see why that happened. Okay, I'm pretty sure I found the error. We made a little typo right here. It's not text embedding ADA 002, but only with 2 Ds. And now let's try making that request again. And now it works just fine. Okay, great. So we've got the success true, a text1 and text2, and a similarity between these two texts of 0.941488, and so on. Really, really good. And now let's try revoking our API key. By the way, we can see the request that we've done in the table right here and how long they took. And then let's revoke this key and see what happens. Let's try making a request with the same API key, and that should come back as unauthorized. And it does because we've revoked the key. Let's try generating a new one and make a new request with this key. Let's paste it into the authorization header, check everything works correctly. And that works just fine. And let's try the last option of generating a new one and also revoking it at the same time. So create new key. That's going to create a new key. We can copy and paste it. First, let's check if the old one is invalid, and it is. And then now let's paste in the new one and see if this works. It should, and it does. Great. So we've done the API route correctly. And now there's one last thing that we want to do for this whole application. We're almost done, and that is protect the routes. As you can see right now, they're already kind of protected, but it just says this page could not be found. And that's not really what we want. If the user is not logged in, as we currently are, like we're not logged in, then we should be redirected to the login page instead of seeing this ugly, this page could not be found. We don't want that to happen. And to do that, we are going to create middleware across our whole application that's going to handle that logic for us. And the middleware we always create at the same level as our pages or app directory. So let's create a new file in the source directory at the same level of these called middleware.ts. Inside of the middleware, we're going to handle all that logic. So first off, let's export default. And from NextAuth, we get something super convenient that is called with auth to use with this middleware. Now the auto imports once again don't work, but we're going to import this from the with auth as a named import from next-auth and then /middleware. That's where we can import this from. And we can invoke this with auth. And inside of the with auth, we can define our async function middleware that we want to handle custom logic in. That middleware is going to get a request that is already typed out for us. And I think VS Code is doing it again. Jesus Christ. So let's let it load. Let's give it a hot second here for VS Code to finish loading. And then I'm going to be right back when it did. There we go. Okay, now I didn't even need to cut there. It just worked. Great. Okay, now the request is already typed as next request with auth because we invoked this within the next the with auth function. And in here we can handle all the logic that we need for our middleware. First off, let's get the relative path that the user is requesting. So the const path name is going to be equal to rec.nextURL.pathname. And that's going to be the relative path of the URL. So, /API/view1/similarity or /dashboard. That's going to be the path name. And then we want to manage rate limiting first. So we're going to rate limit our API. They can only make so many requests per interval. And to do that, we only want this function to run on the API routes, right? Not on the pages. And to do that, we can say if path name dot starts with, and then in here we can say /API. So this is only going to run on API routes. And if it is, then we want to get the IP of the person that is requesting. So we can say const IP is equal to rec.ip. Or if this is undefined, then it's probably localhost, so 127.0.0.1 as our localhost address. And now we want to jump into a try-catch block to handle the rate limiting. Inside of the try, we can say that the const success, we can destructure that, is going to be equal to, and now a package from Upstash is gonna come in super handy that is specifically made for rate limiting serverless functions. We can say await rate limit, import that from Upstash /rate limit. Actually, no, that's not what we're gonna do. Just await rate limit dot limit IP. Dot limit IP. And no, that is not going to be uppercase because this is something we're going to create ourselves right at the top here. So to handle the rate limiting function, first off, we want Redis, right? It's a in-memory database that is super fast. So that's why it's very convenient for rate limiting. We can say const Redis is equal to a new Redis. We can import that from @upstash /Redis. We've already installed all the packages, so we don't need to install that right now, which is good. And this takes the URL, which is going to be equal to process.env.redis_URL. So this is a kind of like a database URL we've got for SQL. Just for the Redis, it's sensitive information because as with a database URL, it also contains our database password. So we want to store this securely on the server side and in an environment variable so it doesn't get exposed to the client side. And then a token property that is process.env.redis_token. underscore secret. That's what I called it in the example env file. Now to get these, we're gonna visit Upstash, and Upstash has two services, which are not two, but the two that we are gonna worry about are Redis and then also the rate limiting. So let me quickly log in. I'm going to do this in my other browser. Let me log in to Upstash right here on my left hand side, and then you're going to be able to see what the console looks like that we're going to be using to manage our rate limiting. It's really easy. Upstash makes it super simple. So we can go into a new database that you can easily create when you're new to Upstash. And then in here, it's going to list our Upstash Redis URL and the Upstash Redis REST token, which is the token. You can just click this copy icon right here for the Upstash Redis REST URL when you're under your project, and then below the connect to your database, this is for the REST API. And we can copy that value, go back into our env file, and then paste that value as the Redis URL. And then similarly, I need to go to the other browser. Similarly, for the Upstash Redis token, we can also just copy this value right here and then paste it into the Redis secret. And I'm not sure why it's blue, so let's put this in quotation marks, save that file, and we should be good to go for Redis. That's all we need to do. It's that simple. It'll take less than 5 minutes to set up. And for the rate limiting, we can say const rate limit. This is going to be super simple. We can just initialize a new rate limit class that we get from upstash/rate limit. And this takes a Redis, which we've already created, and then also a limiter, which is going to be the rate limit dot sliding window, which is kind of like a technique we can use for rate limiting. And here we can see it's how many requests are allowed per window as the first argument, and then combined approach of sliding logs and fixed window with lower storage cost than sliding logs and improved boundary behavior. I don't really know, but it's good performance, and that allows it to scale to high loads, which is good. And just for testing purposes, we're going to pass 5 per 1 hour. So we can only make 5 requests per hour and then rate limit the IP that is making the request. Now, if the rate limiting is not successful, if not success, then we are going to return a next response that we get from next/server.json. And then here we can say error. And what should the error be when people are making too many requests to our API endpoint? We can just say too many requests. And then if people are making more than 5 requests per hour, they're going to get this error for every other request that is above their limit. And if there is success, then we're going to return null or next response.next to pass on the action. Everything is fine and they are allowed to make a request to our API route. And if we're inside of the error, we can just return the next response.json, the same one as up here, but we're just going to change the error message slightly. We're going to say internal server error. And that's the rate limiting done. It's honestly as easy as that. It's super convenient with Upstash. And now we can manage the manage route protection. Now we can worry about protecting our actual routes. And to do that, we know that the user has a JWT, right? And when they're authenticated, the JSON Web Token is going to be valid. And if they're not allowed to access the route, then the JWT is invalid. So first step would be to get the token to then check if it's valid or not. And we can get the token like that, const token, by awaiting the get token method we get from next-auth/JWT. And in here, we're going to pass the request. So they automatically get the JWT next session token from the request. We don't need to pass it in manually, which is super handy. And then const is auth is going to be equal to, we're going to turn the token into a Boolean. So this is either a JWT or it's null if they're not authenticated. And so only when they're authenticated, this is auth is going to be true. And then next up, we also want to determine one thing, which is if we're on an auth page. Because if you're authenticated already, then you shouldn't be able to access the login or the sign up route or the register route. In our case, we only have a login route. but that's fine. So we want to prevent logged in users from going to the login route. We can do that by saying const is auth page is going to be equal to rec.nexturl.pathname, or we can just choose the path name we have defined up here. Pathname dot starts with, and in here we can say /login. So only then is this an auth page that should not be accessed. And then we can define our sensitive routes. Const sensitive routes is going to be equal to an array. We could pass in all sensitive routes. In our case, that's just going to be /dashboard. And then if we are trying to access an auth page and we are already authenticated, if is auth, then that shouldn't happen, right? In that case, we're going to redirect them to the dashboard. And we can do this by saying return next response dot redirect to a new URL that we're going to construct as a class, and that goes to /dashboard with the rec.url as the base URL. So we're passing them onto the dashboard if they're trying to go to the login page when they're already authenticated. And otherwise we can just pass on the request, so we can return null next response.next to just say, yep, you're fine, you're free to go, you're not authenticated, and you're trying to access login. That is perfectly fine, and you are able to do that. And then if the user is not authenticated and trying to access a sensitive route, by the way, we can check if they are trying to access a sensitive route by saying sensitive routes.sum, and if for any route this returns true, the following statement, the path name dot starts with route. If for any of the sensitive routes that's true, they are trying to access a route and they are not authenticated, so they shouldn't be able to do this action, we can say return next response dot redirect, and we want to redirect this user to, again, a new URL that we're going to construct, and then we want to forward them just like up here to the /login. So they're not authenticated, trying to access the dashboard. We're just going to redirect them to the login and then pass the rec.url as a base URL, and that needs to go inside of right here. And then there's one final thing that we'd want to do, and that is pass one options object to the with auth that contains the callbacks. And for the callbacks, we want to define the async authorized function, and for this we always want to return true. And this I wrote this into the GitHub repository. This is a workaround for handling redirect on auth pages. We return true here so that the middleware function above is always called. That's the reason we need to include this. And yeah, now we are almost done with the middleware. Finally, we want to export a export const config to determine when this middleware should run, because currently it doesn't know that. So we can pass an object in here that takes an array for the matcher, and for each string that we pass in here, for that route this API will run. So we can pass the slash for the home page, we can pass the /login, we can pass /register, well, we don't even have a register route. We can pass the /dashboard then any path after that. So we can do :path star to match any path. So it doesn't matter what comes after the dashboard. And then we could also match the /API/ and then any path that follows the API. And now this middleware is going to run when any of these strings in this array is in the URL bar, and determine whether the user is allowed to perform this action or whether they are not allowed to do that. Okay, I saved the middleware. Let's close out of this. And now we already know that the API is working. Let's try to access a route that is protected while not being logged in. So we can close out of Upstash for now. And let's go into an incognito tab. Let's try to access the dashboard. We shouldn't be able to do this. Remember, we're not logged in. And now we are being redirected to the /login. The /login doesn't exist yet. That's a page we completely forgot. But it's a very simple page. We can just fix that really quick. Let's create the login route. That should definitely exist. Let's go into our source and then app, and then let's create an auth in here. And in here, we're going to create a new folder for the login in which we can create the page.tsx that we need for the Next.js route to be working. Okay, now the login page is not going to receive any props. We can get rid of all of this stuff, remove that, and then build the page out together. So the first div that we're going to have on the login page is going to get a class name of absolute inset 0. If you don't know inset 0, it's just top right, bottom left, alt 0 pixels in regular CSS. An mx of auto to center this, a container property. We want this to be flex, have a height of 100 VH, so height screen, flex dash call, items dash center, justify dash center, and I did a little typo there, justify center, and that's it. Then let's format that using prettier and have another div in here that has a class name of mx-auto, flex, width of full, flex-call, justified-center, space-y-6. If you're wondering what that is in regular CSS, it's kind of a little workaround between margin top and margin bottom. It's kind of like the same as gap. We could also say, gap 6, it doesn't matter. And then we can say max width of large. And then let's have one last div in here to make sure the styling is just right with a class name of flex, flex-column, items-center, gap-6, and then text-center. And then inside of this div is not going to be another div, but a link component that we get from next link with a class name of the button variants. So we're going to make this look like a button variants, import those button variants. That's what they're super useful for, just making any component look like a button, even if it's not, just like the link. The variant is going to be of ghost, and a class name, we're going to pass a custom one. Class name is going to be equal to wfit. So the button is not going to take up more space than it needs to. And this link is going to have an href of the homepage. So just a slash to navigate to the homepage within the link. In here, we're going to render out the icons.chevron left to indicate that we're going back to the homepage with a class name of margin right of 2, height of 4, and also a width of 4. And that's going to be a self-closing icon. And the button is going to say back to home. Great. Let's take a look at what that looks like. We can close this tab and go back to our login route, reload this, and take a look at what happened. We can see the back to home button. It works, but we're not done yet with the login page. And let's turn this into a split screen again, so it's a bit easier to see what we're doing. And then after the button, we're going to have a large heading, which is going to say welcome back. And then below that, a paragraph saying, please sign in using your Google account. Great. We've got that done. And then one final thing that we need to implement in here is the actual Google button, right? If we navigate to the login / or we could press on the API key. That's also going to take us to login. We can see back to home, welcome back, please sign in using your Google account. However, there is no button yet to perform that action. So let's create that right now. And let's go into components and then new file. Let's call this component a user auth form.tsx. Oh, and we already, oh wait, that's the original project. Hold up. We want to go into source and then app, and in here, no, and then into components. And in here, we're going to create the user auth form.tsx. There we go. Okay, and inside of this user auth form, let's initialize this as a functional component. And the user auth form, we can extend this to take more props. However, we can also just not do that, make it a bit simpler, and not take this and not let this take any props. Okay, Now for this user auth form, the functionality is going to be very simple. We're just going to have one button in here with an on-click handler, which means we need to use the client directive, use client, and then let's render a div inside of here with a class name of not a regular string, but we're going to use our cn utility function to merge some classes together. Inside of the cn, we're going to have a name of flex and then justify dash center. So the content is in the center, and that's it. And inside of the div, we're going to have a button or a custom button. And the button is going to get an is loading of some state that we need to keep in this component. So essentially, while the Google login is loading, we want to show a loading state inside of this button. And we can do that by saying, or by using state. So let's call that state is loading and set is loading, which is going to be equal to use state that we import from React. That is going to be false by default. And we could, if we wanted to, explicitly type this out as a Boolean value. So if we change it later, we get errors. But we could not do that. It really doesn't matter. I just think it's a bit easier to immediately see what it's about. Then let's create our sign-in function really quick. It's very simple. Let's call it login with Google. It's going to be an async arrow function. And first off, we want to set the is loading to true because we want to inform the user, yep, we're currently loading, let them know that it is loading, which makes for a better user experience. After that, we're going to initialize a try-catch block and try to await the sign-in that we get from next-auth/react. And we're going to pass this a string of Google to sign in with Google. And next up, in the catch block, if we get an error, we want to alert the user with a toast notification. To do that, we're going to import the toast from our custom UI, pass it a title of error. Let's capitalize that. Pass it a message of there was an error logging in. And then finally, the last property is going to be the type property. And this toast is going to be type error. And then finally, no matter whether we error or not, we want to set the is loading to false to inform the user we're done loading. And so the is loading for the button is going to use the same state, the is loading that we have defined above. Okay, great. Now the button is going to get a class name of max w of small, a width of full, and then finally a background dash slate dash 200. Or actually, no, let's not do the slate 200. I think it will look better without it. So what we're saying here is it should always fill up the maximum width, which is going to be small. And on click, we still need to pass that. On click is going to be the function we've defined up here, the login with Google. That is what's going to happen on click for this button. And then we want to pass a disabled, and it's going to be disabled when it is loading. And I think the button does that automatically, actually. Let's check that. Button.tsx. It should automatically be disabled. Yeah, we don't even need to pass that explicitly. We can remove this. It's already going to be disabled when it's loading anyways. Great. And one final thing that we want to display is the Google icon inside of the button, but we only want to display that when the button is not loading, and else in the same spot of the Google icon, we want to display the loading spinner. And the way we can do that is by saying if is loading, then we're going to return null, and else we're going to return the Google SVG. Now, the SVG, we're not going to write ourselves. That wouldn't make any sense. Let's go into the GitHub repository. Into the GitHub repository, and then just copy the Google SVG from there. So visit the repo, go into the source directory, into components, and then it should be at user auth form. Scroll down a bit until you see this SVG right here. And we can just copy that SVG, go back into our code editor and paste the SVG right here inside of the parentheses, paste the Google SVG, and then below the SVG, we can render the text of Google. Great, we are exporting that as default. And now when we go back into the browser and take a look at the login page, we can click there, or we could type it into the dashboard. Well, okay, we're already logged in, so we can't access the login page, which makes sense because we've protected that route. Let's refresh the login, and apparently it doesn't work yet, probably because we've not imported the user auth form on the page. And yeah, we indeed haven't. So let's import it here as user auth form on the page right below the large heading and the paragraph. Let's save that and take a look at this route again. Let's reload the page, and it should hopefully show the Google button. And yes, it does. What happens when we click this button? There was a loading indicator, and then it's logging me in. I'm already signed in with Google, so I don't need to do that again. But in your case, the Google login would pop up if you're not already logged in. Really, really good stuff. I think we're done with the project. The API keys are working, the login is working, the light and dark mode is working. We've got a beautiful homepage with a nice illustration right here. We've got a dashboard listing our previous API requests with different API keys, even if they have been revoked. We've done the database integration. We are pretty much done. If you're following along to this step, honestly, congratulations. You've done really good work so far. Really, really good. And the last step would be to publish this to the website so you can show it off to potential employers and friends, right? And the way we do that is by using GitHub and deploying to Vercel, because that's the easiest thing. You could also deploy this to AWS. I'm probably going to make a video on that soon, but that is probably only suitable for large projects. Let's go to new and then a private repository, or you could make this public if you wanted to. We can call this similarity YouTube, and I'm assuming that you already have a GitHub account right here. You probably do. Let's create a private repository, create repository, and then let's get working on pushing this up to Vercel. So let's go into we can close the original file. We are done. Before we do that though, let's run a final lint to see if we did any obvious errors and if the build would fail that we need to fix. And that is not the case. We can run the yarn build command just to make sure that this project builds correctly before trying to deploy it to Vercel. However, let's go back into the GitHub and then copy this remote origin that we need to deploy this project later. Let's wait for this build to finish, and hopefully it builds just fine, because that means that the production deployment is also not gonna error, which would be great. And it doesn't look like it has any error now. This is totally fine. Collecting page data. Let's give it a hot second and see if it loads correctly. And it did. Great. The build loaded correctly. So that means we can now git add dot. If this is a private website, you don't really need to worry about git commit messages in the first place. So we can say git commit -m and then initial commit. For example, it doesn't really matter what you put in there, as long as you're not working for other people or with other people, then it would actually make sense to have something like a certain rules for what you can write in those commit messages. But for now, it doesn't matter. And then we want to paste the remote origin of our GitHub repository that we got from the GitHub page right here. I can close that. Just paste that remote origin in here, press enter. Now we've added the GitHub repository to this project, and we can now say git push -u origin main. So that stands for upstream. So we're pushing this upstream to GitHub. We can press enter, and that worked. We successfully published all the changes into our GitHub repository. And we can also see that if we go back to the repo, we can see all the files that are in here. Great. And now we can go to vercel.com to actually get this deployed. Let me log in using GitHub, and hopefully I don't have to enter my name again. Great. Now we can click here on the top right side and go into project. And in here, we can import the similarity-YouTube project that we have just created inside of GitHub. We can click import, define all the environment variables. So this is where you just copy the .env variables from your file, like the next auth secret, the Google client ID, the database URL. You just copy the key, go back into your deployment, paste it right here, and then do the same thing for the value. Just copy and paste that as well, click add, and do that for all the environment variables except for this one. We don't need to do it for that. Same for the Google client ID, and so on. I'm probably gonna fast forward this because this is a pretty simple task, and then I'm gonna see you when I'm done pasting all of these. Okay, I added the last environment variable, and now let's click deploy and see what happens. It will now go through the whole build process and log it out right here in the building tab, the one we've previously done. And because we've already built the project, we know this is not gonna fail. You know, it just does the same thing on the Vercel servers that we did locally, which will work. And then we can see our project in the web, actually show it to friends and employees. And one more thing we're gonna do is test if the rate limitation is actually gonna work in this project. So let's give this a hot second to load and deploy, and then I'm gonna be right back when it has successfully deployed. Okay, so it looks like it's almost done. It's creating an optimized production build. So let's give this a minute and see what happens. Compiled. Now it's doing the final lint. Seems to have worked, no errors so far. It's generated the pages, and I think now it is done. Great, so it took about 40 seconds for this deployment. And then in a second here, we should be able to see a message telling us that it has deployed an actual domain in the web that we can then make our requests to. And this is it. Let's give this a second to load the preview, or we could already, yes, very, very nice. Now we can continue to dashboard and copy or just visit this URL, see if the deployment has worked. And it has. We can see the whole page, light and dark mode are working, really nice. And now let's copy this URL and make a request to that in Postman. So let's paste the URL in here, make a post request to /API/v1/similarity, and let's just not include an authorization header, see if that works. It doesn't work, we get an unauthorized. Okay, so let's create our key. Let's sign into the actual web application. Okay, and we also need to include this URL in Google, by the way. That's why we get the access blocked, the request is unacceptable or something along those lines, because inside of the Google console, Google Cloud Console, in our project we used for this app, the YouTube test, in my case, let's go to sign in data, and then to, well, you would have your OAuth 2.0 client IDs. I did this for the actual production project. You would also need to add this domain right here and the domain that you're, if you have a custom domain, that as well. So Google knows this is a valid URL to log in from. I'm not gonna bother because I already did that for the main app, but just add the URL right below the local host in both places for the authorized JavaScript and then the URIs that are allowed, and then you're totally golden. It's very, very simple. And then you can log into your application. We already know an API key, and let's just copy this API key. It should also work in the actual web application because the database is in fact the same. So let's add an authorization header to our request, paste the API key in here, click send, and now we get an error of invalid type, expected object received string, and probably because we have not passed anything in the body, such as text1 and text2. So let's say hello as text1 and world as text2, and send the request again to our actual web deployed endpoint, and it works just fine. We get back the value. Really, really nice. So now we know that this endpoint works. Let's try spamming it and see if the rate limitation works, and it does. We get the error of too many requests. Beautiful, beautiful. And that sums up our work on this app. The rate limitation works just fine, the dashboard as well. And if you add the URL to the Google Cloud Console, then the login and everything else is also going to work. Great work. Honestly, if you followed along throughout this video, really, really good work. I'm sure you got a lot of value from it. I put a lot of effort into making this project and the video and going through the deployment and everything else together with you. And I really hope you enjoyed. I'm going to see you in the next video, which is probably going to be a bit shorter. I'm really not sure how long this is going to be, but definitely more than 5 hours, I believe. So thank you for watching. If you followed along, I really hope you enjoyed the video and got a lot of value from it and are now a way better Next.js 13 developer. That's it from me. Thank you for watching. Again, I'm going to see you in the next one. Have a good one and bye-bye.